Okay, looks like we're streaming live. So maybe Puneet, you can just send that YouTube link again on the chat.
Yeah, so it is taking some time. Yeah, let it start and then I will. Okay, now we are online. Okay, so sir, I just send the YouTube live link also.
Send to copy from the chat. Maybe we can make a nursery spotlight now.
Yes, we can do it. Okay, now things are set. Okay, great.
So should we get started?
Yeah, maybe we can just play one video and then after that we can do it. It's all
Okay,
it's like
so
143 candidates are there. So guys, we will start in another couple of minutes. Yeah, so chill morning. At least at my side, it's very chilled here. It's 3 degrees Celsius right now.
3 degrees. Where are you?
Yeah, it's I'm at Roorkee, so
Wow.
the lowest one is 3. So
20
yeah,
is cold here. So it should come down here.
yeah. So this beard thing, I think after almost like 1.5 year or 2 year maybe. So I'm at my home, like mother place. Mother was asking from the very first day, like, okay, what is this?
Advanced VLSI Lab was set up in 2012, an initiative by Department of ECE and AEI in collaboration with Sankalp Semiconductor. Primary objective to bring our VLSI academic framework closer to the industry and prepare engineering graduates for the challenges in the industry. Conducted industry-grade trainings in the VLSI domain. First major research and development activity resulting in a fabricated chip in a 180 nanometer CMOS in collaboration with Sankalp Semiconductor Private Limited and NIST Barampur, Odisha. Funded by India Chip Program 2016. State-of-the-art information and technology and computing infrastructure with enterprise-grade electronic design automation, that is EDA tools from Cadence and Mentor Graphics, along with open source EDA tools. NDA in place with major semiconductor fabrication founders in the world, giving access to state-of-the-art IC technologies for fabrication. Industry collaboration with major semiconductor companies and skill development institutes to bring world-class research and development experience and industry-grade skill development programs to the engineering students at Silicon. An indigenous, fully in-house chip was designed by 12 undergraduate students in 600 nanometer CMOS technology, fabricated by XFAB, Germany, and fully tested for functionality and performance. In 2019, an extension to the advanced VLSI was added to provide a modern office space environment for industry training and research development work. The lab is equipped with fully networked workstations and AV equipment for fully functional local and remote office environment. In December of 2019, we furthered our goal of bridging the gap by bringing the industry closer to academia. Conducted NES 2019, a 4-day workshop, nanotechnology and embedded systems. eminent speakers from the top semiconductor companies and industries including Synopsys, STM Microelectronics, Savia, VSD, VLSI experts, Tufts University, IIT Kanpur, IIT Kharagpur, IIT Roorkee, KVEC, Mokot, and MSEC. The 4-day event electrified the audience with 11 expert talks on wide-ranging topics, 3 workshops, 3 open house discussions with students, and a very insightful panel discussion. In March of 2020, we were proud to have placed 2 of our BTech graduates in Synopsys, a world-leading semiconductor company, for a full-time position. We are also proud to have our graduates working in other leading semiconductor companies such as ST Microelectronics and Micron through our close partner Savia Multimedia. In September 2020, we collaborated with Boston Microtechnology to develop analog intellectual property blocks for a high voltage power management integrated circuit. The chip is fabricated using a 180 nanometer CMOS technology by XFAB, Germany. In 2019, another extension to the advanced VLSI was added, a fully operational industry-grade characterization lab capable of industrial-grade temperature characterization up to 1 part per million accuracy, a capability only few colleges in the world are capable of. Use of industry-standard test and automation tools such as LabVIEW, LabC Windows, and Python. Advanced VLSI lab was set up in 2012, an initiative
Yeah, so I think, Saro sir, we can start now. Okay, looks like some. Just 1 second.
Okay, now I'm online. Can you hear me now, Puneet?
Yes, sir. We can hear you.
Okay, great. All right, good morning, everyone. Excited to have the third day. I think we've had 2 huge days. A lot of good talks, huge participation, good discussion. So, and like I said yesterday, today is the career day for you guys. So we have 2 great speakers, and I feel like we are in the same company or something. We work very closely with VLSI expert and Savia. They have been a huge proponent for our industry program. So, no better 2 persons to talk about, skill development, career, and VLSI technology than Narsaya Dhanpati from Savia and Puneet Mittal, which will be followed at 11:30. So before we introduce Narsaya, just a quick follow-through of today's event. So the first talk is going to be by Narsaya from Savia, who's going to talk about practical skill sets for the VLSI industry, and then followed by Puneet's talk on the career development as well. just a note, people who are joining in, please shut your videos off. You're obviously muted, just shut your videos off. But be prepared, have your makeups on or whatever you want, because we're going to have some photo shoots at some point after maybe Narsia's talk once and then after Puneet. So we'll ask you to switch on your camera, so have a nice background and, you know, take a shower and comb or whatever you want to do, okay? And also, at the end of the talk, Puneet is going to talk again about the details of the internship program, as well as we'll also talk about the VLSI project, which is specifically for the SIT students. So don't go away after the talk. Puneet will talk a little bit about the details of the internship program. Okay, so I think that's the overview of today's program. Thanks again for all of you joining, some of you in a cold morning, like Puneet. So we'll get started with Narsia. So Chinmay, our anchor, she's going to introduce Narsia right now for the next talk. Okay, thank you.
Good morning, everyone. Once again, and welcoming you to the third day of the webinar, NES 2020. So here today we have Narsia Donpadi. Mr. Narsia Donpadi, he is the co-founder of Savior Multimedia Noida. He completed engineering from Delhi Institute of Technology in 1999. He worked in STM Micro, Electronics Design Methodology team, and later on the AMD as ASIC Design Manager for DTV Xylem series chips. He is the co-founder of Savior in 2008. His primary focus is on technology and project delivery for Saviour's products and services. So now I would like to request Mr. Narsia Donpadi to share his experience with us. He will speak about the practical skill sets for a modern VLSI career.
Thank you, Chinmay, for your introduction. Thanks, Saroj, for this opportunity to share some of my experiences. So let me know if I'm audible, Saroj and Puneet.
Yes, sir. You're
Okay,
audible also and you're visible also.
Thank you. And just pondering over the subject of today's discussion, which is practical skills for modern VLSI career. And I'm just thinking, is there any modern VLSI career, so to say? But I think what people learned 20 years back, they're still doing the same. A lot of my colleagues that I know of who learned how to use a text editor and RTL coding 20 years back are still living exactly with the same skills, with no skills added. So I think to a large extent, VLSI industry has not really changed in terms of the skill sets that people need to possess. So maybe the word modern may sound not so true. The same skill sets are pretty much applicable even now. And in a science conference, I think this talk is probably a bit of a moral science lesson also. So bear with me for that. Let me start sharing my screen and we'll just run through some topics. So is my screen visible, Puneet?
Yes, sir.
Okay, thank you, Puneet. So before going into the details of talk, I just wanted to list down a few exclusions, what this talk is not about. So definitely we're not going to talk about VLSI industry's revenue projections and why this is going to be the best industry. We're also not going to talk about carbon nanotubes and what happens, when you reach 1 nanometer. That's probably not the topic of this talk. Nor are we going to have a passionate rant about what's not good in the education system and what needs to be improved. So this is not going to be any of these. So what is it going to be? It's going to be just talking about, since you guys have probably a lot of you are from second year, third year, fourth year in your colleges, you at least have a year or more which is left with you. Some of you are probably in masters. Some of you have already passed out and are looking for how to make a career in VLSI. So I'm trying to, let's say, crystallize a few skills which can be of use to you to reach a career of your choice. And then the approach you should take in the way you build your skills. And this approach is something that will stay with you once you enter the industry as well, and will help you achieve heights, even though you may not be the most gifted one, right? I think once people enter industry, it's not, I've seen many guys who've passed out of IITs. I've seen people who come from nondescript colleges, and the guys from nondescript are doing much better just because their approach and their mindset is more suited to the job. So I wanted to also share some of those approaches which can help you do well and stand out in your job. Okay, so before we go into what skills can help you get in, I wanted to list down what is the total available space, right? What kind of job profiles are available in the VLSI industry, and what each of them would mean. A lot of you may already be knowing this, but I thought I'll just quickly run through this. So you have a set of people who work on the transistor level. So you have analog designers. 20 years back, people doing custom digital design like memory or standard cells were considered digital. Now, slowly, they also have come under the banner of analog, right? So people who are doing layout, who are doing anything with Spice Simulator, anybody seeing a composer, Cadence Composer window, if he opens this tool, he is an analog designer in his own right. Then there are people who are doing modeling of analog blocks, right? When analog blocks need to be used by SoCs or chips, they need to be modeled. Their timing needs to be characterized. Their behavior needs to be encapsulated in some models. So there are people who do this modeling and characterization. And there are people who are doing PDK development. So these are enablers for analog design. Right? On the digital, we have people who are doing IP design. So these may be specific, proprietary codes. These may be standards. People who are doing a link layer for PCIe or UFS. And there are people who are doing IP verification, which is deep, detailed verification of the IP, right? Using environments like UVM. There are people who do SoC integration. So these guys specialize in bringing in IP from multiple sources and stitching it together into a chip. And there are people who do SoC verification. In a chip, you have 20 blocks. So the focus at a chip level is different. It's not about cranking each and every test case of each and every IP. It is about checking, can all of these come together and satisfy the purpose of the chip, right? You're trying to program a few IPs, and verify whether the data communication between those IPs is happening well for our end-to-end scenarios. And there are people who do the FPGA and emulation, right? So this is what cannot be covered through SoC with simulators. Emulation platforms provide 1000x, speed up to make these end-to-end scenarios possible. And then we come to the implementation space. So there's a design for analog, design and verification for digital, and then there is implementation. So people who do synthesis and timing sign-off, people who are doing design for test, inserting test structures, inserting memory-based boundary scans, stitching together scan chains, doing test simulations, making sure that once the chip is back, there are no fundamental defects in the chip. Then there are teams which do physical design, the real chip implementation, so to say. And there are people who do verification of, the DRC and LVS rules. Then the power integrity of the chip, checking if the IR drop and electromigration are under control. People do packaging, signal integrity, and for some class of chips, even thermal. People who are doing processors or graphics cores. More than any of these, thermal is the most important, right? Because you have billions of transistors and they start producing a lot of heat. And then there are some horizontals like the CAD and methodology, people who do IT infrastructure, people who enable compute farms, LSFs. And then there are labs and qualification. Right? So this is a snapshot of typical profiles which are there in the VLSI industry as of now. And as an entry-level engineer, it's of course, it's always confusing, but you can always, and there are a few entry points for engineers who are entering the domain, right? And there would typically be IP verification, or maybe modeling and characterization, analog layout, maybe synthesis, right? Maybe physical verification and physical design. So, towards the end of the presentation, when we have Q&A, if any of you want more description about any of these, we can discuss. Okay, let's come to the skills. And I think the primary skill that every engineer in the VLSI field should possess is Unix, right? You all have to be very comfortable with Unix as the operating system. You have to be comfortable with using terminal, using shell scripts, basic programs like grep, sed and awk, which are text filters, using plotting tools like GNU plot. I mean, you may always be using MATLAB, but staying in this environment on a command line, GNU plot helps you plot graphs. You should be comfortable with text editors like VI, file management and disk management commands, which help you mount, understand the disk space availability. Again, different situations require different tools. I remember early in my career, we were working on a project which required changing a entire large volume of C code. We wanted to use another library instead of the existing library for performance reasons. And my task was to find out all the instances where a certain library calls for use. It was a pretty large code base, maybe about 10,000 source code files, not lines, files. So, and those days I was learning Perl, and I thought, hey, this should be done in Perl, and spent a week trying to manage the task and my learning, and came out with something. And I went to show it to my leader, and he said, hey, how long did it take for you? I said, it took a week. And then he just wrote a couple of grep commands, and he validated that I missed almost half of the instances. So, of course, probably I was too fresh to know, but in different situations, you have different tools. I mean, there's no need for you to always associate with one set. So you should be flexible to use tools of choice. In fact, sometimes when you become a Unix aficionado, you may start hating Windows programs, but for all the fairness, Excel sheets are not meant only for MBAs, right? So, sometimes you have data which is in a tabular format. You may need to sort, let's say, take a timing report, right? And you may want to slice and dice it as per different clock groups, different slack ranges. And even though your input is text, but taking it to Excel may help you do a better job, probably much faster than using text filters to do that. So all in all, Unix is the first skill that I think all of you should definitely invest on. Next thing is, I think you should invest time in learning a programming language. And this is, again, when I went to look in the web for what are the top programming languages in terms of momentum, I got tons of data. But a lot of them were pointing to Python being the leading, let's say, agent of change in terms of how many people are adopting Python, the number of active Git repositories or project repositories. Python seems to be the one. So obviously, you need to learn a programming language. What should it be? Should it be Perl or Python or Java? Or I think a scripting language is always better for the kind of jobs we do. More than the compiled languages, a scripting language which is good at text processing, which is good for data manipulation, which is good for data visualization, and Python kind of ticks all the marks. And also Python has some very special libraries which help you link to even boards and do some test automation. And of course, slightly embedded in profile, but I think Python has such a wide variety of usages. And I have seen a lot of projects in the VLSI space moving from Tcl to Python, moving from Perl to Python. So it's a good language to invest on. And these are the grand old daddies of the VLSI space. The Pickle and Skill languages have stood the test of time, been there more than 25 years now. I'm not sure any other sector uses these languages, but the investment in the EDA and VLSI space has been so much on these languages that there is definite future for these in this space. So these languages are good for querying an internal database. So if you're using a synthesis tool or a timing tool or a place and route tool, you can use Tickle to query the internal database, find out the elements, manipulate the database, script out your tasks, automate them, right? You can also code design components. Let's say if you're doing a PDK and you need to code a P cell for a MOS, Skill is the language of doing that. That's how you do it. So it's not just optional. In some places, it's mandatory. That's the way you do your work. And how many times have I seen this that, on the day of the project submission, people say, hey, the code was working, but for some reason it's not working now. It was working yesterday. We just made some enhancement, it stopped working, right? Happens a lot. It may be genuine, maybe sometimes not so genuine, but happens a lot to most of us. As we keep working on a code, there are instances in time when the code base works well. And we start trying to implement a new feature or tinkering around with the existing stuff. And suddenly everything is gone. It doesn't work. And it goes so bad, we can't even bring it back to its previous state. So sometimes I've seen people maintaining folders of source code with dates, but all of that is archaic. I think you should get used to a revision control system like Git. There were some earlier like RCS, SVN, and Perforce still there. But I think since Git has come, almost everybody is on Git. So this is a good system to invest some time on, learn it. And especially when multiple people work in a team, right? And you have many moving parts, right? Many source code files being edited by more than one person. There is no way but to have such a system to make this collaboration easier. So I think you should invest time on Git. You will definitely feel much more ready for industry with this kind of practice. So now that some of the basic skills in terms of software and tools is done, I'll come to a skill that all of you should possess, whether you're any of the skill that I mentioned, any of those job profiles that I mentioned. I think almost everybody should understand how CMOS works, right? What is a CMOS behavior across process, voltage, temperature? And I'm pretty sure yesterday, Atul's talk and what Puneet may be speaking about, they would all be talking about this. All of you should understand how basic CMOS works, right? And you don't need tons of data for this. It's all about taking one basic inverter or an AND gate and trying to just shmoo everything. How does it work when I keep voltage and temperature constant, but shift from the worst process to the best process? What happens when I change voltage, keep everything constant? What happens across temperature? What happens to the delay? What happens to leakage? What happens to the crowbar current? What happens to the transition at the output? So you take one or two cells and try to understand the entire gamut of data of interest. I think you will get a very strong grasp, and it's a pretty simple science to pick up. What this also does is this entire VLSI industry is enabled. This large-scale integration is enabled. Imagine somebody writing a system algorithm and that getting implemented in silicon gates. There's hardly a link if you see, but so many layers that help the previous layer be abstracted. So you have the process, which is enabling transistors. So people who are creating those PDKs, process design kits, are helping abstract some of those behaviors for the analog designers. The analog designers, whatever they do, the people who are doing modeling and characterization, they're abstracting the behavior for the digital designer, right? So it's multiple levels of abstraction. So a study of CMOS should help you appreciate what assumptions are being made and how they enable abstraction. So we're assuming CMOS gates are like switches. They're imperfect switches. So what is the range of perfection where we can truly treat them as switches? And then understanding that would be a exercise that help you get your feet wet in this field. Now, since we saw multiple profiles, I'll just quickly describe a few options available for each domain. On the digital design and verification side, I think you should invest time in understanding, of course, apart from logic decomposition, Karnaugh maps, you should invest time in understanding state machines, designing them for real use cases, right? I mean, take a real problem, take a traffic light or elevator, you know, I mean, I'm just describing some very common stuff, but even if you look at bus protocols like APB, there is a state machine. So a lot of things that we do have very basic state transitions in them. So understanding these thoroughly would help you in the design process. Then how data is transferred, right? When you have two clocks which are synchronous with each other or clock domains that are asynchronous, how do synchronous FIFOs work? How do asynchronous FIFOs work? When you do upsizing in terms of bus width, how does that work? How does serialization work? How does deserialization work, right? Then maybe another thing to understand is how the clocks and resets are distributed. Asynchronous or synchronous reset, which one is better, right? And this is so much open source available on the digital IP side. You should definitely spend some time understanding some of these IPs. I2C SPI are like, you know, probably everybody's profile has this, but maybe you can go a step further. Understand bus protocols like AHP and AXI, right? Take a solid IP core that's available in the open course, pick it up, try to understand it, try to verify it, right? Try to enhance it, do something around it, or read a specification. I mean, understanding a spec is not easy. Pick up an I2C spec from Philips. It's not easy to figure out, but spend time to understand a spec, right? Should do such things. In the verification space, apart from understanding some of these specs, you should also build up some knowledge on system Verilog and UVM, right? These have become the de facto, let's say, tools of choice for IP verification space. In the digital implementation space, I think you need to also look and understand the implications of power, performance, and area, right? So we call it PPA. So when you start understanding or appreciating a block's synthesis result, right? Look for what did I get? How much area did I consume? What kind of frequency I'm able to close with? And how much is the power? So these are the parameters that will always be of interest in the entire implementation phase, right? If you're into the implementation space, meaning that you want to be a timing engineer or focusing on synthesis and physical design, you should start understanding some of the formats that are fairly commonly used in this space. You should probably go through a .lib and understand how a library is characterized, how a timing arc is depicted for a combinational cell or a sequential cell. Understand some of the physical formats like LEF, DEF, or an extraction format like SPEF. And I think the most important thing, if you're in the implementation space, is to understand timing as a domain. You need to understand how a design should be constrained, right? And I think, of course, there is a lot of focus on, because there are tons of timing constraints that you can give. But most importantly, just one constraint takes care of 99% of what you need to do, which is just creating a clock. The minute you do create clock, 90% of all the design is already constrained, right? So understanding things around this, what is an uncertainty, what is a setup uncertainty, what's a hold uncertainty, what kind of margins are required, why margins are required. I think this understanding is important to build up, to appreciate the domain. And when you go through those steps, which are from synthesis to physical design to timing, stop at each step and analyze what's happening, analyze what's happening to timing, analyze what's happening to area, analyze what's happening to power, right? So it's this domain happens to be slightly tool intensive, but as you will realize, tools end up throwing a lot of dirt at you, right? Unless you drive them well, it's garbage in, garbage out. So you need to go stop at every step, analyze whether you are closing the funnel or not. The whole implementation stage is like a funnel. So you need to start with high uncertainties, or you start with a lot of variables. But as time progresses, you should converge. You should converge into something that is, from a schedule point of view, from a feasibility point of view, looks more possible to make than probably a month or two back, right? And if you're in the analog design and layout space, you should probably taste a few different types of blocks. You should spend some time understanding basic standard cells, like a multiplexer or a flip-flop, and they're not easy to lay out. And if a flip-flop, once you have to do a standard cell layout with a fixed height, it's not so easy to lay out. It'll take some iteration. So be open to make one, do it again till you perfect it. You should do the same on understanding SRAMs and some infrastructure analog blocks like a band gap or a current mirror, right? And when you do analog, if you're doing a design, also do the layout, right? Layout is, on the analog side, extremely tied to design, right? So do not think that somebody else can do a good job. I mean, you need to first know how to do this good job yourself. Learn to also go through a DRM, a very fundamental thing. The minute, if you want to know more about the process technology, what options are possible, what kind of sheet resistance is there for metals, how much is a rule of thumb for capacitances of these layers. DRM has tons of information, right? We think that it only has those design rules for layout. It has a lot more. So feel free to explore DRMs and understand more about the process that you're working with. And when you do this analog design, make sure that you're comfortable with back of the envelope calculations, right? Don't rely on spice simulators to tell you everything. They can point out your mistakes, but they can also fool you into a comfort zone, which actually may not be there, right? So be in the know of what you're doing. Don't leave it to the tools. And you should also appreciate the concept of post layout simulation. Once you do a layout, capacitances come in, resistances come in. How your design will behave in presence of these parasitics is something that you need. So you start up with certain additional margin in the design. You need to assume and take account of that upfront in the design process. So you'll appreciate the process once you close this loop. And also always do cross-corner analysis, understand how your design behaves in various corners. Because in the end, it's not enough if your design is functional at typical 25 degrees. That's not enough. That's not how chips are eventually manufactured. I thought, what best opportunity than to bring up something like this. So some students, again, we just saw in the video just before this talk. So there are some students in SIT, some of them are with us now, who have done a project under Professor Saroj They built a chip in 6 months. It's in 600 nanometer CMOS, XFAB, has an SRAM, has a band gap, and it's a working silicon, all done in just 6 months, flat 6 months, right? So I think avenues are many to learn. You can always, choose. You don't need to choose a huge project. You can always, for learning, the size of the project is not important. It's important whether you are digging deep enough to not leave anything untouched, right? So at this point, before we go to approach, Saroj, in case there are any questions that you would like me to take. Okay, we'll move forward with the approach. Okay, number one, pay attention to details. This is an industry where the work that you do is, let me put it this way. In 7 nanometer, if you want to tape out a chip.
Sorry, Nars, I had to interrupt you. Sorry, I was not allowed to speak. I am now. So no,
I didn't mute you, so.
No, our organizers are very strict now.
Rules.
So no, it's going good. I think there are a lot of questions on Tickle, Python, is it taking over and all that. But two things I wanted to really emphasize what you just said is one is the analog layout. Like especially here in India, I hear there will be analog designer and I say, can you do layout? So, oh, sorry, I don't do layout. And I just do not understand that concept. I mean, if you're not doing layout, you're not a designer. You're not an analog layout designer. I mean, you're not an analog designer. Like as you said, it's so intertwined. Actually, 90% of your designs happen in analog and layout because that's where you're really making all your creative judgments. Because that's why I don't care about analog papers which are not fabricated because 99% of them will not work. So that's one thing I wanted to emphasize. So if you're doing analog design, you are also a layout engineer. Don't tell I don't do layout. That's mean you're not an analog designer. Something else. I don't know what it is.
Agreed.
But, and the other thing I wanted to emphasize is your back of the envelope calculations. That's some things which I see, just missing completely from students' repertoire. Like they just don't understand that concept. Like one example I'll give you, I was doing this session and I said, I was talking about a wafer size and then suddenly I said, okay, how many chips do you think come out of this wafer, 8-inch wafer and 1 millimeter square chip? And I got 3 answers, 200, 20,000 and 60,000. Nobody ever questioned any one of them. And I was like, how do you, without picking a calculator or anything like that, just doing a back of the hand calculation saying that, oh, I think I made a mistake. This can't be right. 200 seems just absolutely wrong. Like just putting 200 squares by 200 squares and saying, okay, this 40,000 times 3 by 4 should be close to 20,000, then 60,000 and 200. So this is something which misses a lot. So that's something I'm glad you brought it up is, if you want to be an engineer, that's your bane of existence, doing back of the envelope calculation, because things get very, very complicated. And tools are there to find out exact answers. You don't need to find exact answers. You just need approximate answers for you to make judgments as you go on. You can't rely on tools all the time. They'll be too slow. So those are the two things I also wanted to kind of, pitch in there.
Thank you, Saroj.
Yeah, thanks, Nasi.
Okay, on the approach part. So if we start looking at the cost of what we do and how these chips get manufactured, in 12 nanometer TSMC, I think the mask set cost is probably about $3 to $4 million for the entire mask set, and probably in 7 it's $5 to $6 million. So it costs a lot of money to make these chips. It costs a lot of money, lots and lots of money. Which means that in the entire design process, we have to be very cautious to make sure that we don't leave out anything that is obvious. A lot of us would end up working in some things which are uncertain, right? You may be working on the next generation SerDes. You don't even know whether it's going to work, right? There are so many uncertainties. I mean, nobody's going to hold a gun on your temple and say, hey, how did you miss that? But if you tell that, hey, there was this warning in the log file, which is clearly saying that there was some violation and I didn't fix it, yeah, you're not going to get some claps for yourself. So make sure that you pay attention to details, right? I'm not trying to add a certain burden that is not there. There is always a certain burden to that, but you have to be attention oriented. You have to be detail oriented. Do not take anything for granted. That's one more thing about what Saroj was saying, which is do not blindly believe the tools, right? These tools are not perfect tools. They are also evolving as per the requirements of the industry. This is a small industry, so the amount of investments that are done by the tool companies are also commensurate to the revenues they make. So it's not as if they're going to ensure that tools are going to be absolutely perfect. A lot of times in bleeding edge technologies, tools are very, very buggy, and they're still trying to, match up to the requirements of the industry. So anyhow, as an engineer, what can you do? Simple things you can do. Whenever you run a simulation, make sure you go through the entire log, read through every warning, understand why it is coming. Should it be fixed somewhere, right? Should it be something that I need to review and figure out why it's coming? Maybe go through the tool's user manual, understand why this is coming, right? So be detail oriented. Do not leave anything to chance. Mistakes are costly, very, very costly. Next thing I wanted to tell is it's very important to know why your code is working. If it's not working, anyhow you will know, right? Anyhow you will spend time. But it's also very important to know why it is working. Sometimes a certain, you may be given a certain false sense of comfort that the code is working, but in reality, there may be a bug in the code which is helping it work. We actually had a situation 2 or 3 years back. There were 2 bugs in the code. So imagine there is a transformation and anti-transformation. There were 2 bugs in the code and it was working well. Luckily, it was not a fatal issue, but it could very well have been a fatal issue, right? But so be very sure why your code is working. So which means what should be the design process? Design process should be, again, a lot of these practices, when I say code or design, I'm kind of using these words interchangeably because in a sense, it's all the same. Whether you are writing a Verilog code or a C code or putting a certain design into use, first put your ideas to test, right? Go through the loop, go through the logic yourself. Question yourself why this will work, or why this should work, or why this should not work, right? It's no good to, it happens a lot. So let's say that you're preparing a C program and you're somehow not able to get the expected output. You just tweak around a few things here and there, just starts working and you just leave it there, right? But that's a time bomb which is waiting to explode someday. So be sure to spend time on analyzing your code, first designing your code, then compiling, and then trying to check it. So follow the right design practice. So as you, especially for people, again, this is pretty much valid whether you're doing analog part or digital part. It's not enough to just write some, multiplier or SPI and or standard cell designed and done. try to see what is its performance, how much area have I consumed. So have a sense of these, the PPA numbers that I told you, power performance area. Try to see what is it in this that is measured, right? One quick example I can think of, as part of our company, we keep doing a lot of software applications, and we need to do a lot of code instrumentation. So when we write code, functionally it works. We just believe it's good, go ahead. But the minute it's put into a real deployment with 10, 15, 20 users, the code starts crashing, right? The performance is very bad. So start to understand instrumentation, which is measurement of the key critical parameters that's important to the code, right? If you're writing code for embedded, you need to figure out how many bytes is it going to take in that flash. It's not enough to just write code. You need to write code that can perform a certain operation in a certain amount of time, and this entire code space it will take is within the budget that's given to you. Of course, some of these numbers you may not know, but at least you can start measuring. You can start measuring how much is the code space my code is going to take, and can I make it less? What should I do to make it less, right? If I am doing a certain DMA controller, right, reasonable size, first of all, how do I estimate what is going to be the gate count? Hey, let's say I don't have a synthesis tool. I'm starting to write a code. How do I estimate what's the possible gate count? Hey, do I really need a synthesis tool? It'll help for sure, but if it's not there, am I stuck? Should I just not do any analysis? Not really. I mean, chips were being designed even before synthesis tools came into picture, right? People were putting together the flip-flops and the gates all together with hand, right? It doesn't hurt for you to figure out an easy way to give a gate count. So try to understand what are the key critical parameters of your design. And this can be any, it can be software, it can be analog. If it's analog, try to see, hey, what's going to be the marginalities for the design? How does it behave when there is noise in the power? Right? Is it going to have a good noise rejection or not? Right? Again, these sermons or these moral science sermons, they're not arranged in any specific order, so they're coming in a slightly random order. But documentation is not an optional subject. A lot of times we believe that we are now starting to understand design, and documentation is probably an afterthought. But believe me, a design that you have done today, in 2 months you'll forget it, right? So documentation of the design, if it's analog, you'll start putting together all the simulation results, what architecture you have followed, why you have followed this, do you see any novelty in what's done there, right? You put on everything that you need to know. Any other person who's going to come and touch that some other day needs to know. Everything needs to be put. As important as the design itself, sometimes even more important, especially if it's in a maintenance phase. Sometimes we try to, or let's say we are bogged down by the enormity of the task, right? We want to design something which is pretty large, and what do we do? So use very simple principles, right? Can we divide this into multiple parts? Can we use something which is already there at some other place? So when you divide something into multiple parts, question may be, hey, do I need to do everything myself? Or is there something that I can pick from some other place, right? So when you have a larger problem, first try to divide it into pieces, then start seeing, do you need to solve every problem? Then whatever problems you need to solve, get into the habit of doing some planning, some organization, and tracking yourself, right? So if you're a project team of 4 students and you're trying to do a certain project, within yourself, start to track, start to give each other some targets, right? It's important to have some realistic targets and track them. Again, this is pretty overemphasized. Let's say something that I want to emphasize. Saroj, again, some of this content I've picked up from Saroj's slides. A lot of times what happens is when we do these simulations, let's say you have a timing report, right? The timing report has 10,000 Slack violations. And we're decimated. Hey, how come we have 10,000 Slack violations? What are we going to do about this? Maybe what we should do is first understand how many of those Slack violations are 1 picosecond and how many are 200 picosecond. And once you do a visual analysis, you may come to know, hey, there are only 10 of them which are between 100 and 200 picoseconds. Remaining are all probably less than 50 or 20 picoseconds. So we need to have a sense of consuming large amounts of data. And this is something which we need to do almost on a daily basis. We will need to consume timing reports. We'll need to consume cross-corner analysis of analog blocks. So unless you start consuming through visual forms and you help others with such visual forms, it's going to be tough life for everybody out there. Okay, I think this is what we started talking about it much earlier, which is you design, tools help validate. If somebody believes, hey, I'm learning Verilog to design blocks, I'm sorry, that's not Verilog. Verilog is hardware description language, right? It can describe hardware, not design. You design with your understanding and your mind. Languages only help you describe your logic, right? And simulators help validate what according to you is already correct, right? Or maybe what according to you should not work. Either of those, whatever it should be as per you. One problem in the Indian context is, especially because of the maybe this problem was existing a lot a few years earlier, a bit less these days because of open source tools being available. But a lot of learning was kind of restricted because there were no tools available. Tools were expensive, tools were not available for students to learn. I think there is a lot of overemphasis on tools, primarily also because I think the entire education institutions, VLSI labs were also coming through EDA vendors, right? Which had interest in getting those licenses out, But I believe from a pure VLSI perspective, from a design perspective, from a verification perspective, there is a lot of learning which is apart from the tools. There is no denying that tools are absolutely necessary to validate what you're doing, to justify, to go to the next level. But I think to a large extent, this problem is now under some kind of control with alternatives that are available. I don't say that they're equal to the commercial ones, but hey, we have reasons to believe that in few years, they'll be probably as good. One other mistake that we do is, I remember this book, Letter C. I'm pretty sure a lot of you would have learned your C with this book, and many Verilog manuals. A lot of people learn till the first few chapters. The minute we know how to use a if condition or a for loop or a while loop, they were done. We're able to program to our needs. We're done. And the subsequent chapters get very limited attention. So if you were to draw a graph of how many people are studying till which chapter, you'll see that decay is pretty significant, exponentially significant. So it drops down as you go to chapter 7, 8, 9, 10, 11, 12. There'll be rarely people who are going the distance. But I think the problem with that is languages have lots of features that help you express yourself. And if you're going to stop at third or fourth chapter, just because you now know how to use a variable or an array or a dictionary and put some if condition and a for loop, you will be severely restricting your skill set as you move forward. And typically, in learning a language is not like if you do it on a pure need to know basis, definitely you'll stop at the third chapter. But I think you should take a more purist approach to just go and see the end. Okay, so learn to appreciate and practice quality in work, right? None of us are born good coders. None of us are born, good documentation is not about, nice story writing or anything of that sort. These are things that we need to practice on. These are things that we need to work on. In fact, I remember working with one of our teams in our company a year back, and we were almost ready to submit our code into our code repository. We spent 4 days just endlessly cleaning it up, right? So, of course, the easiest way could have been that whatever was there, we could have simply pushed it into the repository and carried on from there. But I think you should have a certain discipline in ensuring good code is kept, is maintained. You start with good code and keep maintaining it as a good code, right? So appreciate that and practice that. When you learn from a book, you know the basics. But if you want to know tricks of trade, hey, open up all these open courses that are available, right? Look for some GitHub projects which have like a DMA. I just saw some DMA with the AXI interface. Very nice coding practices. So if you want to learn the tricks of trade of professionals, if you're in software and you want to learn good coding, you'll probably go and see the Linux repos, how the Linux code is maintained. If you're a Verilog designer, go and figure out how people who are maintaining this open course, how they're maintaining their code, right? So if you're learning to, if you're learning cricket, you'll definitely start watching the Kohlis and Tendulkars of the world, right? Because they showcase the best practices. Similarly, in coding, start looking at the codes that are available from people who are already professionals in this field, and learn from them and put that into your add them to your own repertoire. Very, very important thing. Most of the times you work on others' code, so you need to figure out ways to work with code, be it a Verilog code, be it a design that is already given to you, be it a C code. You need to start understanding somebody else's intention right away, right? If he was a guy who cares, he would have probably provided a good document that could help you figure out. If it was unfortunately a guy who didn't care, he would have just left you with some half-hanging code. But either way, that's the industry. So you need to start getting used to start working with somebody else's artifacts. So I had this very interesting book called Clean Code, and I wanted to read through a certain paragraphs in this just for us to make sense. I mean, this is written by probably the best minds in the software space. And mind you, a lot of design practices in VLSI space are, at least in the way we practice the art, not necessarily from a design viewpoint, but the practices part comes from the software world also. So again, 20 years back when I was a fresh guy, joined ST, we used to have these 5S competitions. So they used to audit our Unix home directories, our desk, to check if we are organized, if we are tidy, if we are having self-discipline. This really helped a lot, at least for the guys who were really bad, the really backbenchers. I think they would always make sure that at least for the 5S, they'll tidy themselves up. One other observation I wanted to kind of bring to your notice. So this is a book which says, back in my days working at the Bell Labs, we had some back of the envelope findings that suggested that consistent indentation style was one of the most statistically significant indicators for low bug density. Difficult to believe, but if this guy is writing, I absolutely believe him. He says just because we were writing code which was consistent, so everybody was, dishing out similar looking code, similar indentation, we could actually reduce a lot of bugs. I mean, it looks too simple to be true, but I think a lot of complicated issues are because we don't follow simple things. This is slightly controversial, but I thought I'll still show this because he says the only valid measurement of code is what you can read here. So if it's a good code, people may still find a few issues there, but if it's a bad code, you're going to hear a lot of sighs in the room. Then this guy says, clean code is simple and direct, reads like a well-written prose, never obscures the designer's intent, but rather full of crisp abstractions and straightforward lines of control, right? And this guy says that clean code always looks like it was written by someone who cares. So I think we all need to decide whether we want to be the guys who want to care. And is there an option? Frankly, there's no option. We have to be the ones who care and keep it clean. So the simple rule is, if you touch any piece of code, make sure that it is cleaner than before, right? And probably if you have not yet joined a VLSI lab, please do that. I mean, this is the time. So we have a VLSI lab in SIT. Professor Saroj is I mean, you guys are really lucky to have him. I don't know, sitting in SIT, if you realize this or not, there are not many like him out there. And if you are in the tutelage of Puneet, again, it's the same for you. We are not many out there who are having similar caliber and industry experience. Now coming to the very initial, discussion I was doing about the title of the topic, which is skills for the modern VLSI industry. So this industry hasn't really transformed in the last 25 years. The design process is exactly same. Whatever it was 25 years back, we have the same process. Now, maybe it's because people are slightly obdurate. People believe that with this exact process, this is the only way to dish out things. But I think it's also probably not the right thinking. So there is this project that's funded by DARPA now, which is the defense institution in the US for advanced projects and advanced research. And they're saying we should have tools which will dish out mixed signal designs and layouts with zero human intervention, right? Of course, they will be not the most optimal, but hey, I mean, 80% of the chip industry is probably not anyhow looking for the most optimal one. So I think there are some new things on the horizon, which will probably start showing up in the next decade. So with that, I think I'll end my session. And Saroj, if you can open this up for questions and let me know.
Sure. Thanks, Narsaya. That was great. I keep telling people these are the things, small things which people don't talk about, but that's what makes up your career. All these little points you mentioned about, just great points. And people get carried away, especially with students. I've seen all the learning fancy tools and all that, but in the end, it basically comes down to the basics. So before I go through some of the questions, maybe I would like to just emphasize some of the stuff you said. Good, clean, essential coding, good coding. That actually applies to HDL, to schematics, to layouts, to everything. And I like the one excerpt you took from the book. Like it says you care. You have a good code, it says you care about it. And that's true with everything. You write a good documentation, it tells you care about it. You do a good schematic, it tells you care about it. And it also helps you because, like you said, 2 months afterwards, like I have a bad memory. If I don't do a good schematic or do documentation, even after 1 week, I come back, I have no idea what I did. So it helps you too. But yeah, just have those practices for everything you do, from documentation to schematics to layouts or whatever you want to do. That's really, really essential for you to take care of it. And people, like as you said, people treat data presentation and documentation as something not part of engineering. But I would say that's more part of engineering than anything else, because the design part or anything you do is actually a very small portion of your entire cycle of a chip design or a software design. Most of the time, you're actually doing presentation, documentation, trying to figure out bugs and this and that, right? So that's. And the other thing, which you mentioned again, something which is not explicitly told, and I find this, sometimes really frustrating with students, is going through log files. People usually run something and say, "Oh, sir, it's not working." I'm like, what does that mean? I mean, is it stuck somewhere? You have an error? Is it crashed? What is it? So, no. It's like, did you look at the log file? No. And you go in the log file, it will say something like 90% of this time it will say file specified doesn't exist. And sometimes they wait, like we have weekly meetings with our project people, and they wait 1 week to say that. I'm like, just need to look in the log file or the output of your log to say that you gave a wrong file name and it didn't exist. So that attitude should come. Most of the time I feel students, they feel like they need to write the code and somebody else will troubleshoot for them. As a designer, 99% of the time you're spending actually doing troubleshooting. So that's what defines you as a designer actually, not a designer and an engineer, not just writing code for making schematics and doing it. So that's what I wanted to just throw out there. So maybe go through some of the questions. Okay, there was a question on fab setup in India. What's your view? I think Mikey is coming up with some fab setups. Well, my view is it should be driven by the industry, not by the government. We've seen that fail time and again. Example is I see a lot of people might disagree with that, but so I don't know much about it, but I would say that should be driven by the industry, and what the government should do is just enable them from an infrastructure side, from cost, from tax side, and that's why we don't have a fab, because China did all those things and they have succeeded in that. So maybe that's say I don't know if you want to add something to that.
Saroj, unfortunately, I stopped tracking the fab discussions a long back. So
yeah, probably a good use of your time. I think.
No, I think yeah, you're correct. From a government point of view, I think there's definitely a lot of concern that somehow this is not happening. I see that concern all around. But you're correct. This is not something that government can set up. It's not just money. You need technology. You need the right skilled people. So I think they can only help from a policy framework.
Right.
Others need to also happen.
Right. Yeah, and my feeling is always the policy is like just get out of the way of people doing things rather than trying to put obstacles. Okay, so there was a question in the beginning. What about, I think when we were talking about scripting language. Okay, so I think a lot of questions have been that Tickle is still around. Should we shift to Python? Or it seems like a lot of the old tools would still use Tickle. Perl, Python, and some are saying like I still use Perl. I don't think Python will substitute that. So
yeah, I think I don't think it's worth the battles.
Right.
We can stay in our cocoons of comfort, yet being relevant. I mean, I agree, but I think in companies which are starting greenfield efforts, Python is definitely a better choice. If you have a legacy which is in Perl, obviously nobody is going to give budgets for converting all of those into Python. I think we will still live with this multi-language legacies that we have. But yeah, I mean, I come across a lot of people who are very comfortable with Perl, who advocate for Perl being the best thing, and I absolutely agree with them. I don't want to probably hurt any one group's feeling there. I think everybody's, but in general, the trend towards Tickle and Skill in their respective domains being very strong contenders, and Python being the new language for teams that are doing automation at a large scale. Again, we're not talking about one individual CAD person who has specific preferences. We're talking about groups of CAD engineers who are where companies that have large investments in this space, how they're moving towards.
Yeah, I think I can make a personal comment on that. I think over a period of time, I moved to Python mostly because, I used to use C for programming. I used to use Perl for scripting. I used to use NuPlot for plotting. So I had all these separate tools. Now I can do all that in Python. So I can script in Python. I can do shell scripting in Python. I can do programming in Python. I can do really good plotting in Python. Like, for example, somebody's written, what about Scilab, which I'm thinking they're talking about the Scilab, Python Scilab modules, tools. So yeah, I don't use MATLAB. I haven't used MATLAB for, I don't know how many years, like maybe 15, 17 years, because whatever I want to do, I usually get done with Scilab. So, and the open source community is so huge, you always get a support for something you want to do. And now we are planning, we started Test Lab, which is, most of the places you'll see it's driven by LabVIEW, but people are slowly moving to Python for that too. So I think from a personal point of view, I think you know Python because it helps you being more productive. And then depending on which project you land with a Cadence Virtuoso kind of a project, you have to do skill there. You land with a Calico kind of a project, then you have to do SVRF, go there, and you do Tanner. So I think it's not like, want to suggest that you just learn one and you're done for life, right? So that shouldn't be the case. So I think Python is good from a personal point of view, and the industry is, all the newer tools are moving in that direction. So I also agree that that's a good to learn. So if you say, okay, I just want to learn one, I would say, yeah, Python would be your best choice.
So one thing I wanted to give as a suggestion. So there are these clean code videos by this gentleman called Uncle Bob.
Uncle Bob. Okay.
Uncle Bob. So they're all on YouTube. Very nice videos, kind of eye-opener. So he'll take very small examples and try to explain why something should be done. Again, I have borrowed a lot of concepts from software for this talk because they're equally applicable to VLSI and the designs that we do. These are things that are making you think more about, are you following the right practice, right? So go ahead, see these videos, Clean Code by Uncle Bob in YouTube, and multiple, probably about 5, 6 of them. Very nice series.
You're talking about that intention. I think that's finally Python, like those guys realize that just force it in the language because follow it. So how much ever books you write and all that. So that's forced in Python now. So which is a good thing. But yeah, because this drives me crazy. Sometimes I get like 1,000-line code without any intention. So that's like
correct.
Okay. So yeah, so there are a couple of questions about, is Python used in front end or back end? It's I guess both.
So I think it's not about front end or back end. I think the EDA tools are mostly on either TCL, or if it's backend layout and schematic, they're on Skill. If it's digital implementation, mostly they're on Tickle. Python is like your when you create your own tools for processing stuff, right? You want to process the reports coming out of these digital implementation tools. For all other ancillary stuff, you use Python, but a lot of these tools are now starting to have a Python API, which will help you query the database using Python queries. So as of now, I see Tickle being the tool for front end and back end, so to say. If you're working in the cadence, virtuoso, or composer, then your skill.
Right. Yeah, exactly. I think personally, I also use it as it's my interface tool, basically. I call it like if I want to convert from one to one or improve my productivity, extract data, plot them, or do whatever, Python is great at that. Okay, so I have a comment from Shrikant. It says, for those students to believe in the approach, like the show ready, comment above, I guess it's comment above somewhere, followed this approach under NERSA's supervision. In 1 year, he's training 60 plus engineers from many countries in an MNC on new IP design. Winners don't do everything, they do things differently. Should apply to this VLSI. Okay, thanks, Shrikant, for the comment. So yeah, this is, I don't think we need even testimonials. These are like golden rules in sort of any domains you want to follow. So great advice. And then this Livia says, Narcissus said, this is a great lecture. It's a good way approach for VLSI questions. Thanks a lot.
So I think one of the questions is on AI/ML and how that will help in HDL coding, to optimize design or verification environments. So I think just like every other domain, just like every other field of science, AI/ML obviously needs to have its own say in the EDA space as well. I think the biggest mark has been now currently on the yield part, where fabs are using it to understand the variance of yield and how they can control yield better. That's where the bulk of outputs have been. In the design space, I think I know of some companies which have tried to use somewhere there is a difference between AI/ML and having a large set of data to make a decision making, right? So I think what they have is a large data set of probably thousands and thousands of digital implementation runs, where they're able to find out which options work better and what has worked in the past for which chip. So that's more, I would say, a collection of large amount of data. Should not be, I don't think they have processing algorithms which will help them understand or call them as AI/ML. But hey, the precursor to any AI/ML is having large amount of data first. So I think people are at least starting to create that kind of data. Eventually, it'll help in putting these algorithms to test, for sure.
Yeah, one thing I wanted to add is like, it's always the case with things which are on hype. People don't understand what they're using it for. So I'll give an example. We're doing this temperature sensor. So we got a data sheet of a temperature sensor, and I asked two students, I said, plot these values, Python, Excel, whatever it is, find out how linear it is, just do a linear fit. And then 3 days after that, they came and they showed me this AI script they used to fit data. And I said, why did you do that? Just use lean. I asked you to do least mean square. That's like, 100-year-old algo, which still works good, very efficient. And, it's, I don't know what the algorithm complexity is, probably even not n squared. And why did you do it? He said, I don't know, sir, AI should be good. I said, did you do any metrics of comparison? Because you're probably spending a lot more computative power and, to get the same data or even worse. How did you know? Did you do LMS? So people, I think, they're just kind of almost becoming lazy. They're saying, oh, I have this. If I apply AI, it should be good, right? So I think that would be my word of advice is that, find out why you're doing it.
So it's like Newton computing his monthly milk bill with log tables, right?
Yeah, yeah. It's like the old saying, you have a pen, that doesn't mean you're skill as fly with that. You can just swat it. Because you blow up your whole house with that. Okay, so we are almost time for the next one. Maybe I'll take just one more question. So I have right in front of me here. There are a lot of questions. Unfortunately, we can't go through all of them right now. So there's a question by Senthil Kumar who says, why most VLSI engineers don't aspire much for a fabless VLSI startup in India? Is that we don't have a good ecosystem for VLSI startup, or academia industry gap is wide? Why possible in USA and not in India, though we have a lot of VLSI labs?
You want to take it up, Saroj, first?
Yeah, sure. I mean, Actually, maybe you're probably the right guy. I mean, I can talk maybe from the US side first. So actually, even in the US side, the gap does exist. Honestly speaking, it exists there as well. I feel the design ecosystem is huge there compared to India, whereas in the Indian side, it's mostly the service side. And now, why don't people aspire to become? So, if your question is why are engineers not going, my argument would be there are not many design startups. That's the first place. So then the next following question is maybe why are there more design entrepreneurs, like entrepreneurs starting VLSI startup? Honestly, I don't know the question. I think it's a composite of a lot of things. Maybe, if you look at the World Bank report, I think we just crossed 100 now for doing ease of business. So it's just tough to do business here as a small company if you have. And getting good engineering talent, that's the problem we have. So in US, although we don't have VLSI curriculums, also there are not that great once you go down the list after top 10 colleges. But the engineering quality is still very good, especially coming out of the masters over there. We still lack that. Our engineering qualities, we produce, I tell people that we produce a lot of students with engineering degrees, but we don't produce engineers. So there's a difference between that. So I think it's a composite of a couple of things what makes the startup VLSI startups not good. But Narsaya, go ahead. I mean, you are in the mix of it, you know better, obviously.
So my take on that is, I think most of the system know-how is not yet there. So, I mean, VLSI is a chip which is going to go into a system, right? So these may be automotive systems, healthcare systems, IoT systems, industrial. So those system know-hows is what would start a component startup, right? So that system know-how in most cases is probably not there. So how would you know what is the missing part for which you want to aspire? I think that's a bigger gap. Skill is definitely there. A lot of people know how to tape out chips. They know very, very well how to meet a power budget, how to meet a safety budget, take it to production. We have the execution skill. But for a startup, what you need is that clear knowledge of what to build. So that know-how comes when you have the system know-how and you know the current gaps and the future trends about where those gaps will lead to, right? And what those new systems would be. And then you go and define a product in that space. So I'm not sure whether we have that ecosystem of system which will enable the component startups to flourish.
Yeah, that's a good point. I guess maybe the follow-up question would be, the systems are all outside India. Why are they not relying to send those chip design work here? Like, why can't we provide them? I think it's the same answer, I guess. It's like because maybe they want it integrated over there than here, right? Like, for example, let's say I want to design the Snapdragon chip for cell phones. Why don't we have startups designing that here? Why is it over there? Maybe because the systems are over there. Is that maybe the right way to put it?
So one of the questions I'm kind of seeing a few times is, sir, how to join a VLSI lab? So I think if you are in SIT, lab is very much in SIT. So
yeah, I just was about to answer it, but then we got into the discussion. Yeah, so the VLSI lab is obviously here at SIT, so the students here obviously can join. We go through a kind of a very I shouldn't say tough, but a good screening process to do people who are trying to do projects here. For outside people, now we have those 4 openings we did for the free internship program, which we just launched as part of this NES2020. So people who are outside SIT, that's the way to get in. So we're going to have those quizzes and screenings and all that. And Puneet is going to talk at his end of the talk a little bit more about it. So definitely stick around. So that's, yeah. Okay, so thanks a lot, Narsaya. We run out of time, still a lot of questions, unless you want to have a last word or...
I think, again, the last word is is what I said in the beginning, which is this is while this is a moral science lecture in a science conference, but I think to care for what we do in all the ways we can is very, very important for the longevity of, for us to enjoy our work daily and for the longevity of our industry, right? We have to be dishing out quality stuff on a regular basis, and that's very, very important. That's something we need to get used to. We cannot settle down for a mediocre deliverable, and be happy with it.
Okay, great, thanks. So actually, the last word goes to Puneet. Puneet, if you have anything?
Not exactly. So I think a lot. I think the topic which I choose, that is the correct one, because if it is something related to the technical thing, then I'm supposed to speak before Narsya sir because he covered almost everything. so
Yeah.
for me, nothing is there on the technical side, like okay, technical skills and all those things. But yes, I was just all the questions which is coming. I have one point. Everyone, like from the foundry point of view, like why we don't have any foundry in India. I'm not. I don't know. On the list which we have and the experience we have, we in the sense the candidates, the attendees I'm just talking about, most of the people are, I think, the freshers, or maybe in the range of maximum to maximum 5 year of experience. I'm not sure like why every time in every conference this question come up, like why the India don't have any fabrication lab. Means what exactly you guys will do if guys will do differently, I would say, if there are fabrication lab in India. Means I'm not sure like okay, here we are talking about the skill set, here you're talking about the jobs, here you're talking about the education system, you're talking about the industry is not helping you. Now how a fabrication lab in India can solve this particular problem? I don't know. Like why every time people are just jumping and they are just making this as a big thing. Like okay, there is a no fabrication lab in India. I don't know. So if there is a chemical engineer and if there are the people, those the constructor, builders, or the electricity department, if they will come and they'll say like okay, now we need a fabrication lab in India because it's going to run 24/7, is going to help us a lot. And if there are people in that particular domain, if they come and they say like then it's good, because real estate will boom, the electricity consumption is going to increase, and everything. But how it's going to change you guys, I don't know. I really don't know that why every time in every conference everywhere everyone is asking the same question. There is no fabrication lab in India. There is a one fabrication lab, SCL Chandigarh, and I think most of you know that particular part. If you don't know, then that's a different thing. How many of you have used that SCL Chandigarh lab? How many of you just connect with them, just try like okay, this is my chip, I want to fabricate it? How many of you have tried that particular part? I really don't know, because I know the SCL Chandigarh, and I think there are very few people. So the amount of time you are asking the question, if amount of a time you will just ping them and just say like, okay, my chip is ready, can you just fabricate? Believe me. So I had a discussion with them. They said if a student will come, then definitely we will do it. We will do it. There are a lot of educational institute. They say like they're ready to work with the educational institute. How many times you ask your educational your college like okay, why there is no VLSI lab and we want to fabricate a chip? So your question supposed to be in that particular way. Not every time you just raise a concern which everyone know there is no direct solution, and even if there is a solution, it cannot be solved in the next 5 years. So what, I don't know. So that's all from my side, sir. So whatever the discussion just happened.
Actually, I would like to, I mean, I can go on hours on this one. But I was just, I completely agree with you that we should not be talking about VLSI fab units right now. The example I'll give is the chip we fabricated, right?
Yes.
That's 1 millimeter square cost us 30,000 rupees. Which college doesn't have 30,000 rupees to fabricate that? Why are you asking for a 2,000 crore fab unit when you can fabricate a 30,000 rupees and test it and do all the plans? So I 100% agree with that. It's like, that's almost an irrelevant question to ask why fab. Because you have access to fabs now all over the world, so cheap, everything. That is a question we should not be asking because we are not ready for a fab, because the fab will take away a lot of the resources into the wrong direction, which we don't want right now. So I completely agree with you that I don't know why they're asking that question, because you can fabricate pretty much in every technology. And local colleges are spending in crores in their labs, and they still don't fabricate chips because they don't have the know-how.
Yeah. You're right. So it's like they can spend 10 lakh rupees in a cadence tool or the synopsis tool lab, and that is just a licensed one. And then again, there are another couple of lakhs in the lab, and they will hire a teacher or the professor. So, but how many of you guys are using that particular lab? That should be the question which you should ask yourself. Tell, let me just answer your question a different way. If you have a chip which is ready to fabricate, come to me, come to Sarosh sir, come to Narsia sir. You just come with that particular chip, like, okay, so if it's ready to fabricate, we want to fabricate it, and is going to change something, maybe whatever the application it is. Like, even if it will take 30,000, 50,000, 1 lakh rupees, we will arrange the fund for you. That's for sure.
Yeah,
So that's
absolutely.
all we can say right now. Means your question is supposed to be, sir, I have the chip is already ready, and now we want to fabricate it. Can you just tell us where exactly we're supposed to fabricate it? Can someone just fund us to fabricate that particular chip? And the government has a lot of policies. The government has a lot of projects, for the fabrication of chip. So definitely this may have some plans. So we should not say like, okay, it's a problem with the government. Also, we should not say it's a problem with the industry, because it's a very big discussion. Like Sarosh sir was saying, it's a big discussion. Means it's just like you are discussing the politics. You're just discussing about the Trump. You're just discussing about the all these things. So I don't think this is the right platform where you should discuss all these things. You should discuss about, you have a chip, you want to fabricate it. Sarosh sir, can you help us to fabricate? And I'm sure we will do something which can help you to fabricate that particular chip.
In fact, just to add to that, when we fabricated the chip, we actually had an area of 10 millimeters square. That was our minimum area. So we went around colleges saying that, look, all you have to do is design and place it. We'll do the pad frame, all the nitty-gritty details to make it work, because that's where the risk factors are. I did not get a single response. So it was finally just us using 1 millimeter square out of a 10 millimeter square. But yeah, so if colleges get together, exactly, 30,000 rupees, you'll have a chip. And or maybe if you want a higher technology, few lakhs. And I see labs around here spending way more money. So I agree.
So it's not about only the colleges come forward and they say like, okay, we are ready to, I mean, so we have the chip. Because I don't want to blame the college right now, because then the candidates will say like, okay, college don't have the infrastructure. But it should be in a different way. It should be like, sorry guys. So it should be in the way like, okay, I have a chip, I would say. I have it, something which can be fabricated, and you just do in that particular way. Yes. So that's all.
No,
That's all from my side.
okay, all right. I think people are really waiting for your talk now. The best is saved for the last. Obviously, before I let Modula introduce you, I'll just speak a little about. So last NES2020 we started. So we met Puneet and we met and we have been collaborating a lot now to get our students closer to the industry. Puneet did a great course on Foundation of VLSI Design in SDA, what is it, March, which almost went like 4 or 5 months. And he was instrumental in getting those 2 people in Synopsys, because just tirelessly trained them for 10 days. So if you want a VLSI job, you cannot get a better guy to counsel, train than Puneet. So I'll let Puneet now take over, but before that, Mridula will introduce Puneet real quickly, and then we can let Puneet start the presentation. Go ahead.
Thank you, sir. So here we have our next speaker, Mr. Puneet Mittal. He is the founder of VLSI Expert Private Limited. He has been working for last several years to bridge the gap between the industry and academia with the help of seminars and workshops and skill developments as well. He also consults the education sector from school level to university level in terms of designing curriculum, training faculties, infrastructure building, and advanced learning techniques using technology. He has been training engineers to develop skills in the VLSI domain. One of his deep passion is career counseling and mentoring. He has trained approx 100 plus students and professionals in the field of static time analysis and foundation of VLSI design across the globe using offline and online medium. His technical expertise includes research and developments for customers after understanding the issues through deep interaction, technical training, static time analysis, parasitic extraction, foundry manufacturing effects, and variation-related concepts. He has worked with different foundries, which includes TSMC, Samsung, GF, Global CP, CSM, UMC, SMIC, Fujitsu, Tower, LSI, and HHNEC. He is an expert in many of the tools required to train students. So now I would like to request Mr. Puneet Mittal to continue the session.
Thank you. Thanks a lot. So let me just do a couple of things. Let me make myself as a spot, I think. Yeah, spotlight video. Okay, great. So I think my background looks good to everyone. I try to choose, like, okay, it should be good. And the lighting is also good, I think. Yeah, I'm seeing myself in the camera.
It looks great, Puneet. Perfect.
So, yeah, so it's like after a lot of days, it's almost like 6 to 8 months. So I'm in a single room almost. So I was like, you can see my hairs are long, the beard was also in that particular way, but good. So so for today, I don't have much slides. Yeah, number of slides, if you can see, is just a 12 slides. So one thank you slide and one start slide, so it's almost like 10 slides. And somehow I'm the one who usually prepare a lot of slides, a lot of animation. But this time I specifically thought like, okay, it should be more on the discussion Q&A session, because somehow Sarosh sir gave me the responsibility, like, okay, you should be in the last, and he mentioned like say he host also. So I thought like, okay, in the last 6 sessions and the 2 tutorials, maybe we can just discuss that particular part if any one of you have any open question. And because everyone all these speakers, they somehow directly and indirectly know me, so whenever there is any career related question, they always pass it to me. So they are saying like, okay, just you will get the answer in the Puneet talk. So this is the time I would say like, okay, feel free to ask as many as questions. And the agenda, the topic of my discussion is going to be a little bit on the pre and the post pandemic era. So the word I have used era is basically because the pandemic is going to be finished maybe in another 1 year or the 2 year, or you can say the effect of pandemic is going to be reduced in another couple of months, finger crossed. So but yes, so that's in the last 1 year, not the 1 year, I think it's almost like 9 months now. It's the March at least it come to India, and as such, it's almost like 1 year. 1 year back, someone figure out like, okay, there is a virus. So the point is, I think it has changed a lot of things. There was a lot of things which we were discussing. We, in the sense, whenever I become a part of a particular conference, we usually discuss a lot of challenges, and always I was talking a lot of things. So I'm going to just discuss those things, and now also. So, and I was just asking everyone just to change their thought process, but everyone was like very resist, like, okay, they don't want to change their thought process. So pre-pandemic, what was the trend? Let me just give you a couple of slides. Maybe it will help you. I don't want to bore you from just my speech. So what was the trend? Trend was like you will enter into the school, primary, secondary, then there is a competitive exams, then you will go for any professional degree. And obviously, so this is a portion like even after getting a professional degree, everyone was struggling. Everyone was struggling a lot, and that's the reason everyone was during the struggle when they didn't find any success, because everyone has their own criteria of the success. What they are going to do, they will start blaming, because the struggle, there is no success. They start frustrating, and when the frustration is there, then obviously they're going to blame everyone. Sometime what happened, they land up to the training. They will say like, okay, we will go in the training section, we will do some training. That I think 3 day before, I was just talking to one of my old student, and what happened, like he was not that consistent, so, and he was just jumping here and there. So I usually use a word of ping pong ball. I think all of you know that particular that ball. So it's, the ping pong ball is just jumping from here and there. So the most of the students, they jump from here and there, and they don't have this. The There is a word like a consistency, so they don't have that consistency word. And if they have a consistency word, it's almost like they are consistent for 2 months, and they say like, okay, that's all. They're consistent for 6 months, and they say that's all. They're consistent for maybe 1 year, 1.5 year, and that's all. So that's a portion like between the professional degree and the struggle and the training, and then the job they're going to do just for the survive. This is the portion where I think the students play a very important role. After that, several years jobs, they will figure out like, okay, they have to do something, they will do certain reskilling, and then finally they may land up. So the important thing is may land up because of their interest. So now what happened, this particular portion, so from primary school to the, or you can say the schooling to the professional degree, most of the portion, if you will see, that is all about driven by the parents or the relatives. So your parents will say like, okay, so you can see like at least in an Indian society, it is like from the very first day, even like in a second class and a third class, they are going to ask, okay, uh, बड़े होके क्या बनोगे. So that's the thing. So see, so think in this that particular way. They don't ask you, they will just say like, okay, then someone will say like your mama, your chacha, maybe some your uncle, they will come and they will say like, okay, engineer, maybe someone will say the doctor, maybe some businessman, maybe like a teacher. So they start implanting the seed in you, like, okay, this is going to be your thing. But actually, if I will ask a kid, do you know what the engineer means, what is the meaning of a doctor, what is the meaning of the teacher, they really don't know that particular part. And that's the reason I'm saying this pre-pandemic thing. So I will come, okay, like why I'm just talking about the pre-pandemic trend. This is the still the trend is there, but yes, this is driven by the parents and the relatives. This is a portion driven by the society. So that's what everyone is doing. That's what everyone is doing. Like after the professional degree, they are struggling, they are training, and they are just getting a they land up a particular job which may be of not of their interest. And when I'm saying society is like, you always compare yourself with someone who's successful. Like there was one example I can see. One of my student, he was not that good in the college, and even when it comes to the from the training point, not the training, I would say that from the learning point of view, he was not even a good learner also. He's a hard worker, but it's not like I would say from the very first day, if you will just say like, okay, just read it, he will understand each and everything in a single at a single point. What is going to happen, he has to read a particular thing at least two times just to understand the concept. So every individual has their own capacity, every individual has their own learning mechanism, or every individual has their own approach. But we as a individual never focus on our strength. We always see like, okay, the other person, so how what exactly they have achieved. So the example which I was talking about, that particular student is almost like 65%, and his friend is also, they are also like in a 65%. So that means both are same, both are living in a same room. And but what happened, his friend, like, okay, so the final goal was like their friend right now in Intel. So now what happened, he start comparing like, okay, these are the same student, the friends whom I was sharing the room, the books, and we were just having the same marks. And he'll end up at a synopsis or the Intel, those land up in a Intel. And why I can't land up in an Intel? I'm eligible for the Intel. And when I had a discussion, hours of discussion, I just dig like, okay, how they'll end up in a Intel. Then a couple of things came like, okay, they were very good in the practical, they were very good in the study, they read it like anything. Yeah, so they were not able to score in the college, but they were very good. And there was a luck also. So it's like they applied, everyone applied in an Intel internship. Somehow they got a call, and they cracked that particular part also. So the point is like, we always compare ourselves with the someone else's success, but we never see like, okay, how they just gone through, like, okay, what was their journey. So but that's the reason I have just mentioned, it's driven by the society. Like, okay, in the society we just do all these things, and this is something which is driven by the passion. Because once you are in the job, then after several years of job, when you're realizing like, okay, now I should do something, because I should do so. There is something, or like you will see like, okay, I the where are the gaps? The gaps is like, you're not skilled. And the skilled doesn't mean in the technical side, it can be on a non-technical also. Like maybe you're very good, but you're very good on a technical side, but you are not good in a presentation point of view. You cannot sell yourself. So maybe what you're going to do, you will just do in that particular way. So that's this portion is a passion. So we are not going to discuss these two things. We will discuss this particular part, because this is the place most of you are right now. And this is the place where I just want to discuss in terms of what is going to be happen, or what happened because of this pandemic. What are the changes you can take care in your lifestyle? What different you can do, so that I think you can just correct this particular portion. Now before that, because I know most of you are going to, you have the same background. So same background in the sense, still you are from pre-pandemic era, so you are from there. So still you have those things, or I would say the seeds in your mind, like, okay, it's a problem with the government, the problem with the education system, problem with the industry. So how things have changed, we will discuss. So these are basically the challenges I'm just talking about. Like as a student, maybe you will say like, okay, it's a problem of the mentorship, problem of the vision. So you will say it's a problem with the mentorship, we will say it's a problem of the vision. We can see it's a society pressure, and but actually it's basically the self interest versus the current work. So some of you will say like, okay, my interest is something, the current work is a different thing. Then the educational institute come into the picture when it is there like in a pillar of education. That the next is a educational institute. Most of you, and like we have discussed several times, like in an educational institute point of view, they are not aware about the current trend, and maybe they are more business oriented. Like just I just gave an example, like the colleges, they spend lakhs of rupees in the lab, but they are not ready to spend maybe the 30,000 or 50,000 rupees for the chip manufacturing. So maybe you can say like, okay, they are business oriented, but that's okay. I think there are a couple of things which we have to accept, and there are a couple of things which we should know, like, okay, how to change it. Teachers, professor, from the challenges point of view, this is again one of the area. Most of the students, even the industry people, even we feel sometime it is because of the teachers and the professors. People are saying like, okay, it's a lack of quality. So my professor don't know a lot of things. Agree. They don't have exposure. Agree. They don't have the exposure, maybe because somehow uh, teaching is a last profession, at least in a Indian society. Teaching is a last profession, and the system is like this. If someone wants to come after the 10 year or the 20 year of experience, if they want to be a part of a particular educational institute, there are a lot of barriers. So maybe that may be one of the reason, like, okay, lack of the exposure and the lack of interest also. And that's again the lack of interest. If you will give a professor the I would say from the salary point of view, the package point of view, will give them a good amount of salary, like the VLSI engineers, the amount of the salary they are getting. If let us suppose in the college they will also pay you in pay not the you or maybe the professors, and they will say like, okay, we are ready to pay you the package of 50 lakh if you have a experience of 20,000 in an industry. I'm sure like there are a lot of industry people, they want to help and they want to do this teaching, but they are not they can't jump right now because somewhere in a Intel on the Qualcomm they are almost getting a 50 lakh package. But in a educational institute, first of all, forget about the barriers and all, because the some it's like you should have a PhD and all other thing. Let us suppose that is again, we will just remove it. But from the package point of view, they will not able to get a 50 lakh of package. Maybe they have to just come up with a maximum to maximum the 10 lakh. No, I'm just quoting a one number randomly. So you can understand like, okay, if you will ask someone just to change their profession with the 1/5 of their salary, it's very difficult. And even if someone wants to do it, their family, so his or her family, they will not allow you to do that particular part. Now when it comes to the infra and the sorry infra and the resources, so what happened, um, from the industry point of view, we always say like, okay, supply not meeting the demand. So we have a demand, but we don't have the correct set of people. And even if that is there, that's scattered, like maybe someone in the remote of Odisha, or maybe the someone in the remote of Karnataka. There is a one college, and that particular college has maybe two or three very good engineers. They are the very good students. Like they are very very good for the VLSI industry also, but they are scattered. And now, from the industry point of view, think like, okay, how a particular company just go each and every college and they will do all these things. They cannot do that particular part. Now, yeah, so pillar of the education, parents are there. they drive the students interest. They will say like, okay, engineer, electronics engineer, or the computer engineers, they will drive in that particular way. And unfortunately they are not that much of aware about the current trend. Like I'm facing this particular problem on a daily basis. All of my students, even now, their uh, parents, so think in this way. It's not like it's not changing, it's changing a lot. But right now, if you have a average age of around 20-25 years, I'm sure your parents are like 50-55 age, near about in that particular age. Now in that 50-55, if people are there, and so that means they have an experience around 20-25 years. So 20-25 year back, there are from the VLSI industry point of view, there are very few companies in India. So you can imagine, like, okay, how many of the percentage of the parents, if they are aware about the VLSI industry? Obviously not. So what is going to be happen? They will just ask here and there, and if someone will say like, okay, no, VLSI industry is not good, then things are going to change a lot. So the point is, these are the pillar of education, and there are a lot of challenges at each and every pillar. Everyone are struggling, and on the basis of that, if there is a education system, then obviously there are a lot of questions, there are a lot of challenges. But that's the reason I just put like a pre-pandemic and a post-pandemic, how things has changed. Things has changed in this particular way. Like, okay, now there is a online awareness thing. So what happened, this online awareness was not there before, I would say, the pre-pandemic, or even if it was there, people were not that much comfortable. Now at least from the parents point of view, because of this lockdown, because of this thing, now they, all of the parents in that particular age, they know there is online, and they have start using the online things. So best example is a Zoom. So right now we are using a Zoom platform. I'm using this Zoom platform from the last I would say couple of years, almost like 4 years, almost like 4 or 5 years. But when it even 4 year back, when I was just talking to someone and they asked me like, okay, how you do the online uh, how you do this online classes, and I usually use this. Okay, there is a platform Zoom. So none of not the none is, I would say 99% of the people, they were clueless. Like, okay, what is this Zoom? Okay, there was a Zoom car. So people start correlating, oh, it's a Zoom car, it's a Zoom. There is a window, there is an option of zoom in, zoom out. So people sometimes become confused as that I'm just talking about that particular Zoom. But now each and everyone, even your parents, you can just go in the remote location, they know what is a Zoom. Okay, because the Zoom has just Zoom become boom, I would say. So the boom, it become like anything. And that's something I was just talking about. Now they know, like, okay, what is a online thing. They are ready to attend the conferences. So if you're a student, what you can do, you can ask your parents like, okay, this is the YouTube, you can just see what is a VLSI industry. You can just listen to these people. They are the industry leaders. These are the people, they are these the successful people. Why can't your parents can come and just attend these type of conferences? They can do it, no one is stopping them. So that even if they have any question, they can do that particular part. So right now, if you are facing that particular problem in a post pandemic, you can ask your parents, okay, there is a conference is going on, there is a conference, why can't you just attend, just check, okay, the industry which I'm targeting, this is the industry. Why can't you just check the facts of that particular industry? Why can't you ask the experts like, okay, I want my kid to be the part of VLSI industry, is it the right industry or not? Maybe the same question which they usually ask in the local people, or maybe their relatives, why can't they do this particular part? They can do it. So the online awareness is there, online awareness in online platform is there. And this is the change which can be done. I'm not sure, like, okay, how many of you have done this thing? If not, just try this particular part. And I'm sure it will be a good thing when you and your parents are sitting in a same room and just attending a particular conference. And maybe your parents can ask, like, okay, why can't beta just ask this particular question, or maybe you can just unmute and can say, like, okay, my father is asking this question, something similar to that particular part. So don't ever come and just say, like, okay, my parents are not aware, my parents are forcing me just to do this particular part. So then the post pandemic, this is a something which can be changed. Obviously you have to drive that particular part, that's your career. Another thing is, when it comes to the infra and the resources, I think you don't need any infra now. No one need an infra. It's just like nowadays, when I was just talking about the scatter and the localize, you will not believe, a lot of companies, have started conducting online tests. They have started conducting the online interviews, and now it's just a matter of time, like when every company is going to reach in the remote location also. Now, what from the college point of view, they always complain, like, okay, the companies are not coming, they are not ready for do the um, campus. Why there is a need of a campus? Like, the company will come, just spend so much of time, and obviously they have to spend the time, they have to spend the money, even you have to do a lot of things. Why can't everything can be done using the online platform? So this is a something which I would say you can push your uh, TPOs, and even you can say, like, okay, we want to do the online campus. I haven't heard anything like an online campus, but yes, the Saroj sir were talking about the two candidates, the two students, the synopsis hired two students of SIT. That's the best example. Everything happened during the lockdown, and everything happened online, everything. So even the I would say the, I think, boarding online, they joined on the online also. So that means now there is no need of as such the big infrastructure, and the company is not supposed to just go here and there. It's just a matter of, like, connections, so that you as a student, you can do a lot of things. Now when it comes to the teachers and the professors, agree, there are, right now there is a problem. So the teachers always come and they say, like, okay, college is not providing us the faculty development program. In the last 8 months, me and my team, we ourselves conducted a couple of technical side. I'm just talking about the online faculty development program. So that means things are going on in that particular direction also, and that's the something I was just pushing everyone, like, okay, why can't you just do it? So I was sharing the same thing long back also, but this, just because of this pandemic thing, things has changed. Now online faculty development program, now even from the student, from the teachers, they cannot come back and they say, like, okay, we don't have the exposure. Okay, so it's the same thing for you. If you want to increase the things, you can do in that particular way. If you want to increase your skill set, there are a lot of things are available. You can just go on the website, attend the courses, you can just do that particular part. Lack of interest, yes. If there is a people, there is a professor, they don't have the interest, and like I was talking about, there are the company people and they have interest and they want to teach you. And now you can see there is an online teaching. So in most of the colleges now, everything is changed to the online teaching. So that time will come very soon, where the industry people, they become your teacher, and the maybe the industry and the academia, they are going to do the collaboration in that particular way. Like, okay, someone from the company, they will just spend a couple of hours with our student. So that means not a single industry people, they have to travel from one place to the another place just to provide the lectures. So everything is going to happen on the online. So the I'm saying the time, the era, in the new era, these things are going to come. So all the challenges, till now we were talking about the post pandemic, there are the challenges, but I can see the bright side of that particular part. Now when it comes to educational institute, unaware about the current trend. No, it's not like are unaware about the current trend. Initially they were also conducting these type of seminars, but now they're calling each and every speaker. Sometime because of this traveling, their busy schedule is very difficult for the speakers to join, to come physically. But now this is the best example, the NES2020. This is the best example. We have connected with the two international speakers, and there are other speakers from the Bangalore, Hyderabad, and you can see like, okay, everyone was here, and is basically uh, they were able to share their experience. So now from that particular part, I think things are going in the right direction. Business oriented, I'm not going to comment on that particular thing, because obviously they are running a business, and definitely they are going to do that particular part. But rest of the challenge, rest of the things, I think it can be done very it can be like uh, control, or I would say it can be solved very easily. Now, when it comes to the student and candidate, I will discuss this thing and again in a detail. But before that, I just want to show you, like from your side, what happened, the way your interest developed when it comes to the VLSI Institute. So this is one of my best slide, like one of my, not the best slide, I would say one of my favorite slide. I always, in every presentation, I usually present this particular slide. So the interest of a VLSI candidate that happened, and for the VLSI thing, like, okay, like I'm supposed to be a VLSI engineer. So what happened when you are going to enter into a college? The first year is going, everyone has a dream, like, okay, I want to do the electronics engineer, because you just study all these topics like basic electricals, basic electronics, network analysis, all these things. Third semester, maybe because of the digital electronics, you may be thinking about, like, okay, now I can be a good circuit designer. So now the things changes, and it become like, okay, I want to be a circuit designer. Now when it comes to the fourth semester, it happens in this particular way. You start working on a microprocessor, and you think like, okay, you can do a lot of automation. That means you can do a very good automation. So you start thinking like, okay, you want to be a automation engineer. But in the fifth semester, when the controller and DSP will come, then you start thinking like, okay, embedded engineer is a good field. So this is the thought process, the way the first year, second year, third year. In the fourth semester, sorry, in the sixth semester somewhere, what happened when the courses digital design, advanced digital design, they came in your they become the part of your curriculum. Then you start thinking like, okay, VLSI engineer. But this is only for the one semester. The moment the last year will come, again, because of the society, because of the peer pressure, because of the family pressure, and because you were not able to decide in the entire so many years. So what is going to be happen? You'll say like, okay, the campus interviews there. I again want to, at least I should be an electronics engineer. So yeah, so someone was just commenting, just pop up a comment, and they're saying the software engineer. Yes. So that's a different thing. Yes, people start thinking like, okay, they want to be a software engineer. Yes, good. I think that's a good point, and I will just correct it and just make certain changes here. I will say electronics slash software engineer. So the point is, this is the journey, this is the way your interest develop. And now think this particular part. Now we are talking about the VLSI engineer. Now think, in the sixth semester you start thinking about the VLSI engineer, only for 4 months, because sixth semester is basically the 4 month semester we are talking about. It's start usually in the Jan, Fab, or and in the June or July. So just for a 6 month of time frame, you realize like, okay, you should be a VLSI engineer. That's on the basis of the VLSI design and advanced design. I'm not saying that's your problem. I'm not saying there is something which is like you have to fix. No, you cannot, because there's a philosophy behind this, the way the subjects are there. I don't want to change that particular part. I'm not going to suggest like, okay, just make these changes. But the important thing is how you're going to make changes. If you are aware, maybe you can do a lot of things. So just to give you an idea, like, okay, pre-pandemic, post-pandemic, virtual platform. So maybe all these this video is already online. You can just go back and just read it, what I was just talking about, and already I have covered this particular part. Like most of the classes on the training online courses are there. Even the companies are there now targeting very specifically, and they are looking for people even in the remote location. So that's one difference in the pre-pandemic and the post-pandemic. Now what you guys can do as a student. Now the way I'm going to present the next couple of slides. So every time what happened, I usually suggest a lot of solution. And last time when I was suggesting a solution to someone, so someone just asked me like, okay, Puneet, you are suggesting so many things, but how many of them you are ready to do it? So it's like people suggest a lot of things, but what exactly they are doing to solve that particular problem? So what, in a different way, or I would say, I'm also going to do certain marketing about the VLSI expert, like the initiative which we have done in the last 1 year, 2 year, so that at least uh, no one is going to ask me this question again, like, okay, Puneet, you are not doing anything, or why can't you start doing something? So I just want to highlight that particular part, like, okay, this is the thing. And definitely everyone is doing their company promotion, so I think this is the best platform where I can just add a couple of slides there. So yes, now let's see like what is the first step. So now this is something I'm talking about from post pandemic. Now what exactly you have to do in a pre pandemic, from the awareness point of view. Whenever I used to present this, like, okay, you should be aware the conferences, you should attend the conferences. As such, no one asked me, and no one just highlighted this thing, but I can understand it's very difficult for them just to travel and attend the conferences. Even if they can, if they are willing to do it, they have to take a lot of permission from the college. And it's very difficult even for the colleges also just to communicate everywhere, like, okay, we are conducting this conference, why can't you just come and just attend this conference? So like now let us suppose to, in the last 2019, the SIT college, they tried, like, okay, in the nearby colleges students should come and attend the conference, but they can't communicate to the college in the Karnataka, or maybe someone in the north, or maybe in the south, like, okay, just come and just attend this conference. And even if they will communicate it, then everyone is going to ask you, like, okay, who is going to pay, and this is very far. And then again the infra problem is always there, like, okay, in a single room in a college, if there are thousands of people, how they are going to accommodate those students, or the attendees. But now in the post pandemic, this is the best example which we are doing right now. And as a VLSI expert, we have started this expert talk, is a series of a talk a long back. And the purpose of that talk was just to connect the students or the candidates with the industry expert. So, and that was a series of talks. So it's not like just one talk in a 1 month and done. It was like we have decided, like, every year, every month, we are going to do it on a third Saturday of every month. And that's we started with the 3 speakers, then we did 2 speakers also. So last one was with the 2 speakers, and these are just 3 posters I have just put it. But if I remember correctly, we did it almost like 6 7 three, yeah, 4 plus 2 3, something like that. So there are the expert talk in a different topics on a motivational side, also from the technical side also, just to give an idea also that these are the things, and we are going to continue this particular part this month. We have associated with the SIT, and we did it in that particular way. So that's the one thing. I think this is going to be a best platform for you just to get an awareness about the VLSI industry, which you can do from the second year also, third year also, and you can do in the fourth year also. So the point is, if from now you will say like you are not aware that there is a VLSI industry, I would say start attending the conferences, and start attending the conferences. Maybe it's VLSI from the embedded, for the computer science, and just see like, okay, what exactly is going on, and just ask the question the way this time the participant just ask the questions in a similar fashion. You can ask a lot of questions, explore. The next thing is once you're aware, then the next thing is in which particular field what exactly you should do. So always I ask to my students or the candidate or those who just call me for the mentoring, and they always ask like, okay, we want to go into the real estate industry, we want to join a VLSI industry. And I'm sure like most of you want to know, want to all of you guys may have this question like, okay, how to enter the VLSI industry. Now the question come, if you are going to ask this question to a particular industry person, definitely they're going to ask you like, okay, for which particular profile you want to enter, what is the job type, what exactly you are going to do the job, what do you think, how many fields are there in the VLSI industry, what is your interest area, what is your expertise, what exactly the skill set you have. Now till now, in a pre-pandemic, the things are in the reverse way. So in the reverse way, in the sense, you will ask your friends, they will say like, okay, go to the verification, you are going to attend a particular verification course, and then you will get certain expertise. Maybe that's not of your interest area, and then you will start searching the job for that particular part. And later on, then you will see like, okay, my interest area is something else, because this is something is not giving me that particular kick. So then you're going to change your field. But now in a post pandemic, the way I'm just trying to suggest you, why can't you just go with the online tutorials, just attend the online tutorials, the workshops, just do that particular part to understand what is your skill set, what is the things. Just go and just do the assessment platform, use the assessment platform. So a lot of people, they say like, okay, I'm very good in the digital. Now your digital and my digital, when I'm saying your digital and my digital is same. But when it comes to the digital, it is basically basic digital or advanced digital. Whatever may be the advanced for you as an industry person is basic for me. So when I'm going to, if you are going to ask me like, okay, which subject, what exactly I'm supposed to do, I will say like, okay, you should be very good in a digital. Now, yes, sir, we are good. Yes, Puneet, we are good in a digital. Then it's always, always. I always make a statement. If you are saying you're good in a digital, and I can prove you, I can not the prove in the sense just forcefully, but yeah, I always say like, okay, I can assure you that you are not good in a digital, because that's a something you think digital, that you are good in a digital. But what, how you are assessing yourself, you are assessing yourself because you have gone through certain books, you have got your you can solve the questions asked by your friends, maybe your digital marks are good, that is your assessment thing. But are you using any industry standard assessment platform? No. Or are you have you ever attended the question sets which is related to the your digital? How many interviews you have attended that things? How many, how you're saying in terms of like your digital is good from the uh, problem solving point of view? Have you done any tutorials or the workshops which can prove like, okay, your digital is very good? That's just an example. So in a post pandemic, now what exactly you can do, you can attend a lot of tutorials. There are, so this time in this conference, what we did in a NEST 2020, what we have done, there are two tutorials, and those are both the tutorials, and I'm very happy, like most almost like from the attendees point of view, there are almost like 200 people over there. So those type of tutorial both are free of cost. Then why can't you just go and just attend those tutorials? You can do that particular thing. Now, if you are going to ask, like, okay, Puneet, what exactly you are doing? So we have our e-learning platform. We have assessment papers also. You can just go and just attempt those assessment papers. Few are paid, few are free. Even the paid one is very less in amount, I would say, worth to invest, I would say. There are a lot of uh, tutorials or the workshops that is present on my YouTube channel. So you can just go and just check on the YouTube channel. There are a lot of other channels also where you will find a lot of material. So my point is just explore the different fields. Learn through those pre-recorded sessions, through those YouTube or the articles. You can do in that particular way. Explore it and try to get the skill set or the interest at least. So there is no harm to have to know each and everything. I'm not saying to become expert, but you can know each and everything from RTL to GDS. What's something is going to stop you to gain that particular experience, that particular skill set, I would say. So skill set doesn't mean I'm not saying you become expert. At least you should know, because if you know everything, it's very it's going to help you a lot in the industry just to survive, not in the survive, just to perform very good. So that's the second step which I am going to recommend, like, okay, you guys should do that particular part. And the third is learn. So you can see the explore there. I was talking about, like, okay, you should explore the things. You should know the things, but I haven't mentioned the learn. Now the third thing come into the picture, that is the learning. Now the learning in the pre-pandemic, training and the internship, I think that was the only one, those two things which you can do. So in the training, the specific training about for the courses, you just go and just attend those particular part. So if I will ask you, like, okay, just attempt multiple trainings, it's not possible, because physically presence is not possible everywhere, and you have to travel also. You have to spend a lot of time in the travel. Maybe the one best institute is located in the Karnataka, and you are in Bhubaneswar, or maybe like you want to go with VLSI expert, and but you are in the Bhubaneswar, or maybe the Karnataka, or maybe somewhere else. But it's very difficult for you just to come and just attend all those offline classes. You cannot do that particular part. But what you can do, if you have to do the online, then you can just go for the online training, and you can do all those things, because now at least institutes also understand from the learning institute point of view, like, okay, the online is the best platform where they can contribute a lot. There are few, they have started long back. I'm from the very first day, like, I'm online. So I think from that point of view, uh, things are going in a good direction on my side. But I can see in the last 8 or 9 months, 10 months, there are a lot of institute now, they become online. So that's the one thing. So online training, you can do it. You can go with the pre-recorded training also. So if you want to learn it, that's I'm just going to give you one more slide. I'm going to discuss like what exactly I'm talking about, the systematic thing, what you can do it. But there are a lot of online trainings are available. It's a low cost in nature, and that even if uh, you're not going to get a expertise using that, but at least you can learn a lot of things. So you can explore using the free material, you can learn using the paid material, you can do that particular part. Even now, there are a lot of online internship is going on. In the last 8 months, a lot of companies, they have started the online internship. uh, there are the free also, there are the paid also. Paid in the sense they are going to give you the stipend also. So those things are there. We also started. I am sure like most of you know, like, okay, there is a free internship program which we have started, the second one. Now we are doing as a under the brand of a semi scout. It's a VLSI expert I would say the initiative we are doing, and I'm very happy like SIT is helping in the Savia is helping in that particular part. So we will discuss about this internship program more um, uh, today at the end of this session. So if you have any question, you can ask there. We have also asked couple of things in terms of like a few months back we have started this gift of bundle where the industry people they came forward and they gifted the bundle to the different candidates also. So we are doing in that particular way, not we, there are a lot of other people also they are doing in the similar fashion. So the point is if you want to learn you can learn this particular part, and this is a something which has forced not the force I would say which just happened because of this pandemic thing. Now this is the slide which I was talking about from the learning point of view, like okay, what exactly should be your approach. I am sure most of you are waiting for this particular part, like okay, what should be the journey now, what exactly you should do this thing. And this is almost the last slide, so if you're thinking just trying to bore you, that's not the case. So yeah, so this is the thing. So first you have to attend the conference. It is going to open your mind, I would say. Then you can attend the workshops come tutorials, again that is on the practical side. So when I was talking about the workshops come tutorials, so obviously that's basically you can see like okay how the tools are working and how the same concept we can apply there. So that particular part is the workshop come tutorial. The third is use of free resources. So till now we in the sense as I can see a lot of students they were not ready to use the free resources. And one of the reason like those free resources are not systematic in approach. They those are not like well defined thing are there. But I can see over the period of last couple of months there are a lot of companies they come up with the free resources, and that particular free resource they have arranged very well. So that's a one of the next step. You should have a free resources. After that there is a some paid courses. So this is the same part which I was talking about, the as a part of a explore. You can explore yourself with the paid courses, the pre-recorded. Now I'm not talking about right now the training, I'm not talking about the online training, I'm just talking about the paid courses with the pre-recorded thing. So like there are a lot of platforms out there. There are Udemy courses, there are the Coursera courses, even we have our own e-learning platform also. So through that you can just go and you just attend those paid courses, just explore like okay, these things are done, this is the next portion. Now this is the open source workshop, I would say. So in this particular open source workshop mostly what you can do, just one second guys. Yeah, so in a open source workshops you just understand this particular part. So this is something is going to help you to map all these things, whatever you have done in the first three. It will help you to just to work here, like okay, there are the open source workshops, there are the tools are there, how you're going to implement, how you're going to do certain things, whatever your skill sets. So assessment you can do yourself using this particular tool, or you can learn a lot of open source tools also. So yesterday Rajat gave you a very good idea about the RTL to GDS, and he explained in a very good manner. I think that's more than enough for any student just to enter into the VLSI industry if they know all those concepts. Then you can just go with the projects. So once the workshops are done, small workshops are done. So I have seen a lot of people, a lot of students, they come up with the certificate, like okay, I have attended this particular workshop. What exactly I'm going to do if you have that particular workshop? Until unless you will say like okay, I have done the project on that particular workshop. So yesterday also in the Rajat I have mentioned like, okay, there was the recent incidents. One of my student, he attended a interview, and in the interview I just asked like, okay, what exactly you have done? He said, like, okay, I have used the OpenSTA, which is an open source tool, and I did my ST analysis. So they asked the interviewer directly asked like, okay, the open source tool OpenSTA, what exactly you have done there? So he said like, okay, I analyzed the reports, the different inputs, output files, and the reports also I have validated through the manual calculation. So the moment he mentioned this thing, like I have validated using the manual calculation, people are that the interviewer just asked, okay, what calculation you're talking about? Okay, what exactly you have done? How tool happen? How tool behave in a particular scenario? From where, which particular file, which data you have picked for that particular thing? It's a just a single word. It's a just a single project. They did it. They just did it using the open source. They just analyzed the report. That's all they did, this particular part. But the way they did it, that's matter a lot. So the project using the open sources, that's what I'm saying. You should explore the tool. You should see like, okay, how to fix the different problem. If you are able to come up with a project, which obviously you guys should have done that particular part. So if you will come and you can able to explain that in an interview, I think that's more than enough. And even if someone will say, okay, you don't have a industry standard tool experience, I think that job is not for you. So if anyone is going to ask you like, okay, you don't have any industry standard tool experience, don't go there. Okay. Then live training, yes, this is all done. Maybe after this you will come to know like, okay, still you have time, or still you want to upskill yourself, then you can just go with the online training, because there are a lot of things here. Maybe everything is a self paced I'm talking about. So there are a lot of questions, there are a lot of doubts, maybe you have in the till this particular point. Now question come, how you're going to ask. For that you need a mentor. You need someone who can just tell you like, okay, this is the thing. So I think this is a portion where you should think about the live training or the offline training or the online training. Whereas the live, when I'm saying the live training is the offline training, and this can be the online also. Because by this, because at this stage you have a good idea about everything which you can do yourself. And after that, if you're going to interact with the mentor or the trainer, you can ask the questions directly. So last time when I was talking to, when I was just presenting in one of the conference, the one question come up, how we will come to know like, okay, whether the training institute is good or bad. I think if you have done your homework, if you know all these things, you can easily figure out which trainer is good, which training institute is good. Because the moment you are going to interact them with a 1 hour or 2 hour, basically you can do all those things. So the point is, till now, the people are doing assessing you, and you're just joining on the basis of, because someone just tell you like, okay, that institute is good, why can't you just join that particular part? But now if you will do this homework, then you can assess like, okay, whether this particular institute is good for you or not. So I'm not saying a particular institute is good or bad. It's basically it's like the physics, there is a resonance. So in my college days, there are two physics teacher. One is ND sir, so Narsinga Das sir, and there is another one is Kuchal sir. So these two professors are there, and the best, the equation between them is Nursing Das sir. He's a physics IIT like the professor. He was there, and a lot of people are doing a PhD under them. And one of the professor, one of the I would say the this is the Kushal sir. Now students have a mindset like, okay, Kuchal sir is doing a PhD under Nursing Das sir, so maybe he don't know a lot of things. And frankly speaking, if you will ask me, for me, I was able to understand the lecture delivered by the Kuchal sir compared to the Nursing Das sir. And there are few people, for them the Nursing Das sir was good, because they were able to understand their approach and the way he explained the people. So what the reason I just gave you this particular example, that training institute, the professors, it doesn't matter. Means you cannot say like, okay, if 5 people are saying it is good, he is good, then you will say like, okay, he is good, or this that institute is good. It depends on you. Like, okay, where maybe this resonance frequency is the synchronization between you and your professor, the teachers, or the institute is there or not. And till now, in the pre-pandemic, that was missing in most of the students, because they don't know how to set the frequency as per the professor, or as per the trainer. But now if you will do all these things, then it's going to be very easy for you to synchronize yourself, or just to check whether the other person frequency is matching with you or not. If it is matching, then it's good. So that's the place I'm just talking about. You should come up with the live training, the offline training. Internship program. So this is internship, like till now, like I said, it's very difficult to travel and do the internship, but now it's the online offline internship. So there are a lot of opportunities you will get as the online internship. Just attend that particular part. So I think that's a point where you can just go with the internship thing. Self assessment, that is very important. Like, okay, everything you are doing, you should assess yourself. Until unless you will not assess yourself, don't come and say like, okay, you are good. And how you're going to assess, there are different ways. One of the thing is, just go with the some assessment papers, or the some use of some assessment platform. And that assessment can be in terms of the return, or the your expertise, or related to the uh, also the marks, maybe in the marks base also, or maybe it's something else. But at least if I will ask you like, okay, how you are saying you're good, so you should have certain parameters. Till now in software industry, there are a lot of self assessment techniques, like they have the hackathon, they have the different platforms are there. In a VLSI industry, there are very few platforms you have where you can just assess yourself. But yes, people are working on that particular part also. And the last one is the mock interviews. So before landing up for the interview for the job, I think this is the area where you should work. You should do the mock interviews things. Like, okay, first attend the mock interviews with the industry people. So this is the place. I think this is the place where you should use your resources, your relatives, your friends, and you just ask them like, okay, why can't you just take a mock interview? So before you come and you say like, okay, I'm ready for the job, I have each and every skill set, and YPA industry is not hiring us. I think if you will do all these things, then it is good. Then you can say like, okay, now I'm good. And I'm sure if you will follow this particular step, then definitely you will get a lot of referral itself. Just one, I think 30 more seconds, just to give you an idea what exactly we are doing as a VLSI expert. What are those areas where we are working right now, and how we are working. And there are a couple of areas where we have plan. So on conferences, we have similar thing like an expert talk, workshop come tutorial, that is in process. So like 2 workshops we have conducted with the help of SIT, Rajat and Steve Howard. And we have planned in a coming in the 2021, we are going to start a series of similar type of workshops. And don't worry, that's going to be free of cost for all of you. Like, if it is a if it is going to be paid, that's a different thing, but yes, it's a free of cost. That's a plan right now. Free resources, I think most of you know very well. There are a lot of blogs are there. There are a lot of YouTube channels are there. From our side, I have started this blog 2010, 2008. So that is there. YouTube channel 2000, I think 14. We have started. You can just go in the We'll Say Expert YouTube channel. There are a lot of free resources in our e-learning platform also. Paid courses, there are pre-recorded if you're talking about. So we recently launched our e-learning platform where there are a lot of pre-recorded courses, and we have a plan to just do a lot of things. So we have already talking to a lot of industry people. And but yeah, from the quality point of view, we are making sure like, okay, things should be in a good direction. Open source workshops and the project using the workshop that is in the process. Like I have mentioned, that's a plan for 2021. Live training, that's the first thing we have started as a VLSI expert. So we are doing a live training. Online classes is already there. Offline is we are based in the Noida. We are doing in the Noida, and like we have also done in the last year in the Bangalore also. Internship program. So under the brand of a semi scout, we have started this thing. Already we have mentioned like, okay, that the internship program is going on. That's something we have already announced and at this particular platform. So that's there. Self assessment, again, you will find a lot of papers for the other for the self assessment point of view, that is already there in our e-learning platform. Mock interviews, this is something is going to be the part of a semi scout, and there is obviously I'm doing till now the mock interviews on a like a just once in a while. It's not like a regular activity for me because I'm busy in other things. But I'm doing this particular part even now. A lot of people they approach me, they say like, okay, we they want to do a mock interview. But 2021 the plan is like we are going to do it the more professional way, like maybe the regular activity and all those things, and we'll see. I'm not going to comment on that particular part. Is going to be the completely free or it's a completely paid, or if it is a paid, what is going to be the model. That's something we are going to plan it in the 2021. We have our own app for the mentoring and all other purpose, but for the there are a couple of things which we have to just solve it. So from the last 2 or 3 months we were planning to start this thing, but yes, the reason there is a green color because that's already is done, and we are going to do that particular part in the 2021 more professional way. That's all. Thank you. I think that's all from the speech point of view. Now it's your time. You can ask questions. I can see there are very few questions, only 20 questions, not even the 20 questions. I'm good. I'm open now.
Yeah, that means you did a great job of presenting it. I think a lot of well, I can't say thank to you, Puneet, because you're the host. But thanks anyways. That was, I think people always enjoy your talk. And by the way, the stairs you saw, by the end of it is the door to synopsis and intels and cadence and all that. So I think maybe next time you can, not necessarily, not guaranteed, you still have to get the skills. But yeah. So Puneet, do you want to just go through the questions, or maybe read out? Do you want me to read out some of these? I think,
Yes, sir. So I can read. I'm just checking like, okay, from where I'm supposed to start. So I'm just checking the time frame. So I think I
yes.
started around yeah. So I think it's until 10:41. 10, yeah. I think the first question was I wish more number of institute. There is a okay. So there is a one question. I'm graduate from IIT Dhanbad, attended 6-7 interviews, but every time some new type of questions come up. How to manage this?
Yeah.
Good question. I think Ajit, you have asked a very good question. So the best answer, and which the not the best answer, I would say the best approach. Uh, See, I can understand, even everyone can understand. You cannot answer each and every question the very first day until unless you are well prepared. But there is no definition of a well prepared. So every time you will see there are a few new questions, and sometimes it looks to us like, okay, because of those new questions, I'm rejected. So the best part is after every interview, just write down all the questions before the next interview. Make sure you should not miss to revise those questions, means you should have the answer of those questions. So as far as I know this industry, if you have attended 6-7 interviews, and if you will just list down all the questions, if you will list down all the questions, I'm sure like okay, after 6 7 interviews, now you have a your question set which can help you to crack any interview, because after 6 7 interviews, 8 interviews, people are going to ask you the questions which is the subset of your that particular whole things. So I think that's the approach you can do it. That's the best way. Next is like those pillar everything I crossed in my life. I think okay, that's the proper way. Okay, thanks a lot. Vipin was saying many companies use the most of 2 year of recruitment, but why companies are less interested? They this year, in fact, in this IITs and NIT. Yeah, so I think Vipin, the best answer, and anyone can give you any industry people, but from my side uh, I can say there are a lot of uncertainties, and it's not like they don't want to hire you. There is no requirement. There is a lot of requirement, but there is a lot of uncertainties. In the sense, if you will see. When we were in the March, it was the we were predicting like okay, things are going to be good in the month of April. Then it become May. Then it was like in a summer season, like in the June, everything is going to be okay. In the June, the things like in September. And in September, people start realizing like, okay, this is really a pandemic is not going to finish very soon. So then they have started about this particular part, like, okay, they are going to start that thing. Even in the companies also, I'm not sure like how much you know, a lot of companies, they now most of the companies, they are like allow their employees just to work from home till March or the June 21. That means now you can see the now they are certain like okay, next next 6 months nothing is going to change. So from that point of view, now companies are hiring people. So it's not like companies are not hiring, but they're that's the one way. That's the one thing I would say. Second thing is because of this uncertainties, obviously economic point of view, a lot of things has changed. A lot of companies, they delayed their project, and that's when the new project will come, obviously things are going to change. So you can see the automobile industry impacted a lot, and because of that, a lot of things are going to a lot of things are going to change. So so answer of your question is, it's not like companies are not interested, it's just like they were not certain what exactly they should do. And you will see slowly now the things are going to change in maybe in the next 3 to 5 months. So yeah, so 2020 is something maybe you can just remove from your profile. Okay, so there are a lot of things just happen. Now there is a one question like why companies are why the companies recruit from tier 1 college and about the remaining college. I think I have answered this particular question. They have a they can't go to each and every college, because if that's the case, then they have to hire a team of experienced people, and they have to ask them like okay, it's India tour. So just go spend 2 days in a one college and 2 days in another college. So it's not going to be a their technical jobs it's going to be a not even the marketing job, it's become a hiring job. And if so how many engineers they want to do in that particular way. So everyone so the best is whosoever proved in the past, just go there and just hire people from there. But it's not like companies are not hiring from the tier 2 or the tier 3 college. They are hiring, but yeah, limited college. But like I said, now after the pandemic, things are going to change. Now it's a matter of how you're going to project. If someone is going to refer you, definitely company is going to hire you. That's going to happen. Next question, will SI company started offline recruitment also, even when it is not possible to travel? Yeah, so I think that is okay. If it is not possible to travel in this pandemic, you can say like, okay, I don't want to, I can't travel, but that's a company decision, like, okay, how they want to do it. But there are a lot of companies, they have started the online recruitment also. Offline maybe they are doing because they need a local people, because maybe so some company in a Karnataka, in the Bangalore, they are pushing and they are forcing people to come offline, maybe because they know like okay, it's very difficult to do their job in a online, and they need someone who is a localized. So that may be one of the reason. Then I think thanks a lot, Sai and the Senthil. You're just sharing your experience, and then people are sharing about the e-learning platform, YouTube channel. Rajat video, Natarajan, you will get it. It's on our YouTube channel. Then what else? I think, sir, everything is done almost. Then after that, it's just like a thank you. And there is a one question. So many companies want MTech in VLSI industry. I have
Yeah.
done the BTech. Yeah. So, uh, Shivam, there are so many companies they want MTech in VLSI industry. Now, this is the thing which you should think why they need a MTech in a VLSI industry. The reason is your seniors. So in Hindi, it's like Purvaj. So your Purvaj, your college Purvaj or the BTech seniors. So what they have done, they haven't performed good in the interview, and somehow the MTech people they perform very good, and that's the reason the company was like, okay, MTech people are more mature, so let's hire them. That is one of the reason. But as such, there is no criteria right now. There are few fields where we need a MTech because we think that that is something is present in their curriculum. But if you are the trained, if you know those skill set, you can apply that. But those companies also, you have to just prove your skill set. That's all. Then MTech is a good option. Then the training in, oh, that's a good question. So someone asked like, okay, which option is good, training institute or the MTech? So if you're doing it MTech from IITs, ISC, and a tier one college. So I'm just talking from the current trend. Uh, then MTech is a good. And but if you are doing a MTech from a college where you have done your BTech, and I think in that particular case, go for the training institute. It's the same thing. So even in that case, you can also go into services companies also. So there are a lot of people they say like, okay, why should I go for a 15,000 rupees job? So the simple calculation, spending 2 year in the Amtech program, you're going to spend around 4 to 5 lakh rupees plus other expenses, and even after that, you maybe you have to do the training because you're not, it's because that may be not a good college or not the same thing. Now, from the earning point of view, maybe you're getting a 15,000 rupees first year. The second year, you're going to get the 30,000, and then maybe you're going to get around 60,000 rupees. So you're earning. There is experience also. There is something like you are not spending from your pocket also. So it depends on you. Like, okay, whether you are good in mathematics or you are good in listening to the people. It depends on you. So if you just want to do the same thing which everyone is doing, then you can decide the MTech and all those things. But if you think you are good in mathematics, you can do all those that particular part. There is a, I think, one more question. Third year BTech started exploring about the VLSI industry sessions with I was occupied with some daily, which was not there before 3 days. Thank you. Okay, that is a thank you one. I think that's all, sir. I think I've covered almost every question. Am I
Yeah, I
right?
think one question is basically it's asking why there are not many VLSI startups in India. I think
Okay,
Narsha
great.
kind of answered it, but yeah, go ahead.
So for the VLSI startup, there are a lot of VLSI startups right now in India, and their working models may be different. It's just a matter if you are talking about the startups from the product-based startups. So you have to be specific. If you are saying from the product point of view, uh, uh, like, okay, you need a startup. They are doing the product development. So there are companies they are doing product development. Yes, there are companies, but it's difficult for you just to find out because those are startups. And the problem with the startups basically, so they need very few people, and they are not good from the very first day in the marketing or the branding point of view, because they are working on a particular product and then they will do the branding and everything. So I think your question is valid, but not the same context. Like, okay, why there is no startup? If you have a startup idea in a VLSI industry, just let us know. So I'm also working with a lot of startups in Noida, and that's my one of my side job, I would say, the interest area where I'm helping the startups for the promoting, just to uh, redefine their ideas, just to those things. So if you think you have a good idea, just ping me any point of a time. We can discuss your startup idea, and we will see like, okay, how to take it to the next level. Okay. Why VLSI freshers are paid less? Because if you are not good in a skill set, people have to train you. That's the only thing I would say. Now, if you are good, then you will get a good payment also. But again, miss, that's a general answer. But there are companies, they are paying very good. So now the definition of a good or the definition of a less and the more, that is a different thing. So the one thing is, always you have to remember, don't think from the starting point of view, like whether they are paying you the 15,000, 20,000, 5,000, 10,000. Things from the growth point of view. So if you are comparing from the software industry, you're comparing maybe the TCS Wipro, and maybe you are thinking like they are going to pay you the 3.5 and the 4 lakh rupees from the very first day. But go and just check their growth rate. So maybe after that you will get the 20%, 20%, 20% increment, or the 25%. But here, maybe the first year you will get a 15,000, then the 100%, 30,000. Then you will get maybe 100%, 60,000. And then you will, after the 3 year, maybe 60,000 and 12 is a 77.2, that package I'm talking about. And then you can just directly into the 12 lakh package, 15 lakh package, 18 lakh package. So the jump is like this. Every year, the growth is going to be like this. So start maybe very less, but see the growth. So now it depends on you whether you want to see a start with a 3.5 or the 4 lakh of package, and the over the period of time your package is just like 3 to 10 only. And in the VLSI industry, maybe your package, starting package, it's like maybe the 1.8, but over the period of same time frame, maybe you may cross like 30 lakh of package. So this is the companies, like I can say today, 10 year of experience, people are getting around 50 lakh, and I know people, they are getting around 80 lakh package also. And with a 15 year of experience, the people's salaries are around between 75 to the 1 crore. Now just go and just check any software industry, especially the I would say uh, the the software industry like TCS, Infosys, or then we will talk about that particular part. Okay, so I think that's all from my side, sir. Now, internship portion we will discuss in a couple of minutes. Just give me some time and let me just charge my laptop also in the meantime.
And there's a special thank you from Satabdi and Prachita saying thanks for helping our SIT students. So yes, from all SIT, we thank you for helping
Thanks
our
a lot.
students.
That's my pleasure. I would say like I got a chance to help you guys.
Sure,
But
sure.
it's not like me. I would say it's because of you, and I'm very thankful to you guys. Like, okay, you guys are in a big platform, also in the small platform, also you guys are always just appreciating me. So I would say it's about you. It's about your capability. It's not about me.
Exactly. Okay, great. So I think what we're going to do is show, Puneet, should we do a photo op right now and then do a
Yes,
little
sir.
thank
So
some and
we can do it. Just give me 30 seconds. Let me just charge my laptop in the
sure,
meantime.
sure. So in the meantime, maybe the participants can switch on the videos. So we'll take a
Maybe you were discussing something, sir, about the projects which you are going to do. Maybe you
yeah.
can just do that
So
particular
yeah. So
part.
while they're switching on, maybe we can quickly go through that. Before I do that, I just want to do a quick thank you to the team. So let me just share really quickly. Uh, Yeah, so while you guys are getting your cameras on, maybe I'll just go through a couple of slides. So yeah, so I mean, the first thing I wanted to do was when we have a great event like this, it always comes with a great team. So I was thinking I'll just go through the team and thank everyone. So this was obviously in collaboration with VLSI Expert and SIP. We don't have Puneet here because he's in Noida. We just took these two pictures right now. So this is the whole team. So first I would start thanking Dr. Samitra Das and Dr. Kiranchi for venue coordination. Switch this up. And speaker invitation and QA compilations. A lot of things are going in the background which you don't see. So these are the people who help us with that. And then for registration and certificate design, also blasting emails and all that, Dr. Bhagilakshmi Jena and Niharanjan Panda, especially, Nihar, he was instrumental in blasting all those, because once we got 1,600 participants, it started becoming a challenge, so he did a great job of that. For media design and program scheduling, Dr. Soumya Samal and Mrs. Annapurna Mishra. Again, there's actually a lot of other activities happening behind by these people, but I'm just putting at least their main responsibilities. Technical support, social media and promotion. Satish and Santanu, I can't thank them enough. It's like a constant thing going on in the background. So all the Zoom settings, YouTube Live. Obviously, the picture which is missing here is Puneet's. Puneet is also part of this. And there's a lot going on behind this. Thanks. And this whole thing would have just collapsed online if these two people were not helping us. So, and Santanu is also charge of our advanced VLSI lab. He's kind of mostly taking care of most of the activities of our lab. So people who are interested in joining the lab will, be constantly interacting with him. Then Prashant Swine and Isis Swine, they're actually our lab assistants. So they take care of all the lab infrastructure, our new test labs. Plus they help us with a lot of the technical support for this NES as well. And then there are a lot of supporting staffs which you don't see, like people who are providing tea, to moving chairs, to lights on, closing the day. So thank you Vishnu, Sangram, Govinda and Dheera for all that. Student volunteers, again, all the big creatives you saw was from the SID side was Akash, Somit, and Chinmay and Murdula were the anchors. You probably saw them every day. So thanks a lot for doing a great job. I was just telling Chinmay and Murdula, like at your age, I couldn't speak 2 words in front of 2 guys. So you guys do a great job of speaking, doing public speaking. And then a lot of the graphics design, which was done from Puneet's side, was done by actually MFox, by Frame and Ijaz. So great job again, guys. They put a lot of extra hours, overnight hours to get things done, because this was almost a last minute decision for us. And obviously, last not least, but because this whole thing is the initiative from the Department of EC and EIE, so our HOD, Dr. Vishwit Baral, and HOD of EIE, Dr. Amrish Mahapatra, they are the key drivers behind. So the big executive decisions are done by this, like telling our trustees this is, so it relieves a lot of pressure from my side. I don't have to deal with that. So thanks again, Dr. Baral and Dr. Mahapatra for that. And obviously Puneet, just maybe a quick anecdote. So when we first planning this, it was like almost a late decision. We decided, yeah, let's do an online one because we couldn't do a physical one. So I was calling Puneet that, I need you to speak on 17th, and he's saying, yes, I'll do it, but I have my VLSI expert on 19th. It will be a little bit this thing. And then I said, why don't we do this together? And that's how this whole thing started. So it was kind of almost an impromptu decision, and I couldn't be more glad, because he's the main driving force for driving the entire online platform and everything. So thanks a lot. Thanks both our SID team and VLSI and Fox. Obviously, like I said, this was a huge success. So without a great team, it's almost impossible to do. All right, thanks. And I'll just quickly, I guess you guys have been seeing before we do the photo op. and the internship thing. We've been doing these videos, so I thought because a lot of people have been asking on the chat about the VLSI program, so I thought I'll just quickly go through that. So this lab was actually started back in sort of 2013, 14, legally 2012, but that's when it started by Sankalp Semiconductor. So the photograph you see here is Mrinal, who was heading the Sankalp Semiconductor then in Bhubaneswar. So this was started as a kind of a 20-25 seater with workstations, and, ran a lot of courses. But the main R&D effort which came out of this was actually a chip was first fabricated, I believe, 2016 in collaboration with Sankalp and NEST Berhampur. And this was a chip which was fabricated in UMC 180 nanometer and funded by the government program called Internship program. So people who were asking about the fab, this was actually Silicon didn't pay any money for this one. This was actually completely funded by the Internship program. But Silicon, NEST and Sankalp were decided involved in it. We have a pretty good infrastructure here. We have a 60-core compute server, a big file server, which sits in the server room, and we have a gigabit fiber network which connects to our various labs. So we have a training lab with 30 workstations, and last year we actually created a training room, which is kind of a corporate style training room for training as well as R&D effort. In fact, the room I'm speaking from right now is converted. That lab is converted. And then we have enterprise tools. So we have the full Cadence suite, the mentor graphics, and obviously because of the whole pandemic, we started running all our open source tools as well on that. So very enterprise level infrastructure. We have engaged with a few fabrication partners. We work very closely with XFab. Europractice is a consortium, so we have access to a lot of the technology nodes there. New Semi gives us all the high-end low nodes for TSMC. And again, these are not super expensive at all, so you can pretty much fabricate in any one of them. We have a lot of industry partners. Savia obviously has been with us since 2018-19. VLSI expert from last year's 2019. Actually, see if Srikant online. I don't know if you want to speak on. Is he online? So hi Srikant, if you're online, maybe you can speak a little bit about your experience.
Hello. Hi Saroj, how are you? Good afternoon,
good.
Everyone.
How are you? Listen to us. Hi Srikant, can you hear us?
Yeah, I can hear you.
Okay. Yeah, very quickly, if you can speak about your experience with this collaboration we have had, so that will throw some light on, what
it is. I remember that we had discussed about this in 2018,
right.
December, right? It's 2 years now.
Yeah, right.
Things have moved pretty quickly in these 2 years, and I was very happy that you are there and doing this. And as Narsaya mentioned, many people don't know a lot about what Saroj has done in the past. He has very illustrious background. Anybody, whether it is ST or Intel or anyone, would love to have him as the chief designer in their company anytime without blinking an eye. And he chose to be in Bhubaneswar and wanting to guide this laboratory. This is how, things ittafaq, they say, right, in Hindi. I live in Noida, so I learned a little bit of Hindi. So that is what it is. And I was very glad, Narsaya was very glad that we took the opportunity to support the lab. And we have, I think, more than 10 people with us from this lab from various years. And the collaboration is growing. And we want to do design of digital chips also within the lab. We have also some of the Savia employees going back to the lab and working in Bhubaneswar. We don't want to treat that as a pure academic setup. We want that to be a kind of industry oriented design collaboration. So we can talk further about the growth of this. I could not visit due to the pandemic over a long time. And this conference is fantastic. I think many times people are repeating on the basics. Maybe everyone is wondering why it is so. Me, now a parent of teenagers who are in college and going to be in college soon, I can tell this very much. It is the same I hear from their teachers in the PTMs. So there is no difference. Unfortunately, what happens due to the easy availability of software jobs in the country and the BPO jobs, we have forgotten the basics of what is the meaning of an employment and what should we aspire to do as part of our job, and what is the relation we should have with our team and the company and the customers. These are fundamental things, right? If you go and ask a person working in a bank or in any other traditional job, the industry which has been there for decades in India, they would tell you these without any hesitation. But if you ask a technology person, they would be pretty confused. What is this? Why should I listen to this person, that person? Should I be reporting this? Should I be following guidance or not? Should I stay for a year or 6 months or 2 months? When should I switch? All these complex, uncertainties and pulling these thoughts spoil the whole industry, I would say. Now we are turning back to basics, not in a good way, in a little bit bad way, I would say, because the employment scenario is not very good now. And people like Puneet are very few who talk about this in a very open manner. They can be politically, very easy for Puneet to be correct being politically, right? To say that all things are fine and you just get into a training institute and you'll be taken care. It's not so. Very few can boldly talk like he is talking. Please pay heed to what he's saying. Use the resources wisely and stick to the basics. And in terms of the opportunity, we don't see anything going away, especially because in the West, when I was at DAC a year back, the huge talk was how we are missing youngsters in VLSI industry in USA, which is the truth. Many people, Saroj is a PhD from USA, so he knows the firsthand the situation there. The youngsters taking up VLSI is coming down in the universities there, same in Europe. But we need electronics for the entire world. The pandemic has proven how important the technology is for the human beings. So there is a great opportunity, provided we can step up and be true engineers, true scientific people, not just pushing buttons and running a tool and writing logs and saying my job is done to our manager, right? So wish you all the best. And I hope Saroj and Puneet will give the platform to people who are true aspirants in one way or the other. You don't need to be enrolled in a college to get their help, or you don't need to be sitting in Noida to get guidance from Puneet. They're very resourceful. I'm wishing you all the best. Thank you, Saroj, for giving us an opportunity to work together, and it's our pleasure.
No, thank you. It's our pleasure. Our main giving that word of advice, and it comes from someone who has been in the industry for 20 years now. So take heed to it. So thanks again, Srikant. So yes, our main goal when we first started this lab was to bring the students closer to the industry, and we are kind of doing the opposite to now. We are getting the industry closer to us also with these collaborations. So, we have collaboration. Boston Microtechnology is someone we use to develop some IPs that will show. So this is the first chip we developed at the lab. This is purely for a you can say a training purpose, and it's fully tested. It had a SPI, SRAM plus a band gap with a few other IPs. So this tells you that even if you're a small college with very limited resources, doing a full chip is not a problem at all. It's just you need the know-how. So I just want to go into the detail, and this is what we did just in September. We developed some of the IP blocks for a chip, which was for central fabrication. So this is a kind of innovative chip for a 600 volt design for chargers, and we developed some of the IPs here, like all the BICE, the DAX, IDAX, the band gap references, clock generators, SPI, calibration register, and all that actually was done in this lab. So this is the training hall I was talking about. So this kind of serves as a training platform conference. Plus, I'm speaking from it right now. So the TV you see at the back is the TV behind me right now. So we've been, like Srikanth was saying, we just don't use this as an academic platform. So this was actually part of the industry. This was the first training batch we did for analog design and layout last year. So, and we have currently employees who are doing verification training right here, right now. So this is another characterization lab we started after last year's NES 2019. I think in the video you might have seen that this is one of its kind. You don't see that in most of the colleges in the world, which is true. It's not because it costs a whole lot. It's just that because of the know-how. If you're in the industry, this kind of a characterization lab is almost essential, whereas you don't see that in the universities because it's just a lack of know-how. So now we have a full-fledged characterization lab which can go all the way to like measuring 1 ppm voltages in voltage references. So yeah, and you know, as we've been talking throughout, we have people being placed in, you know, the two Synopsys employees, full-time employees last year we did, and again, thanks to Puneet for that. He's solely responsible for that because he kind of did some really intensive training for it. Then obviously we have Sevia, obviously is our big partner. Through Sevia we have people now in ST Microelectronics and Micron in Hyderabad as well. And since last year's NES 2019, we have been running some industry programs. The first one obviously was run by Puneet, which started right at the beginning of the lockdown. Same was the case for the Synopsys one, like he mentioned. It was actually the day the lockdown happened. That same day in the evening, I got an email from Synopsys saying they need some guys. So we started the whole thing online, and you know, we were successful with that. This initiative started last year, where we decided to bring in both academia as well as research or industry people together. It was a huge success. Like, I think what we had 8 talks, 3 workshops, a lot of open houses. It was just a huge success. It motivated a lot of our internal students and so on. And you know, there were people from IIT Kanpur. This was Dr. Behera, Chivu, who you saw on the first day. Atul, you saw him. This thing. Srikanth was there. Unfortunately, he wasn't there this time, but Narsaya took his place. Savia's team doing a workshop, and then my friend from Tufts University gave a great lecture on nanoelectronics. Then obviously, I think most people probably know Kunal Ghosh is an online phenomenon. He did a great workshop on RTL to GDS2. Then from IIT Kharagpur, there was Vibhu, who gave a great talk on data converters. So yeah, so there was a, and then, sorry Puneet, our photographer went to sleep, I think. There was a couple of talks which are missing from here. But after this, you know, obviously because of the pandemic, we said, okay, we just, last minute we decided to do a very small scale online webinar, you know, the NES 2020. But, you know, lo and behold, this turned out to be even a bigger event participation-wise than last year. So that, you know, thanks to all the organizers and the participants for making this a huge success. The talks were great, the discussions were just phenomenal, the workshops went good. So you know, we had Shivu again giving a great talk on you know, chipsets. So last time we couldn't get Micron, but this time we had Dr. Vishal Sapani from Micron. Again, that was a great talk and discussion on the future of present and future memory technology. Steve Hoover, who's in the forefront of this new EDA development tool called TL Verilog. So everyone got introduced to that. Again, great online workshop. 250, 270 people, I think, were there for the whole 1.5-hour session. Okay, it says 263 here. So that was a great one too. Then Rohit on the embedded side, again, I wasn't aware of this TinyML movement. So that was a great lecture, and I think we have to do a workshop with him. That was a great talk, and just can't wait to have an online workshop with him and just start some of that development in our embedded lab as well. Atul, of course, is always from ST Microelectronics, is a crowd favorite, so he gave this great talk on what's the present and future of VLSI and how ST Micro has contributed to it. So that was a good one. Rajat's tutorial was awesome yesterday. Very well designed. People were just engaged throughout. So thanks Rajat and his team for that. And then obviously today's talk by Narsai and Puneet, where, you know, like I said, it was a carrier footprint. It was a carrier program. So so obviously we are proud to announce this free internship, which Puneet started, but we decided we'll do it together this time. So Sevia is there, will be there, and then there will be a few more maybe companies coming along. And I also wanted to mention that this is a platform we used last year to screen our students for the lab. We'll do the same thing. So it's the same quiz, and then we'll do some interviews after that and some other short videos. So that's it. Quick one. So everyone was kind of plugging their company, so I thought that we should do that for our lab as well. So, so let's do the photo up. See how we do this.
So you have to unshare, sir, and then
Yes. Sorry. Yeah.
we have to remove the spotlight also.
Yes.
And then we have to wait that, okay, everyone should switch on their camera.
Yeah, so please switch on your cameras, and or if you at least have a profile photo if you feel like.
I think everyone can switch on their camera. That's not a problem.
Yeah, please switch on your cameras. We'll do that.
Okay, great. I think okay. So few people are, their faces are good.
I think all of them are good, so looking good. And I thank you all for staying for these long sessions. You know, it's you guys who, I mean, you guys have been thanking us, but it's really you who make this successful because of your
So I'm still seeing people are switching on their camera. Okay, guys. So if everything is done, everyone is done, we will just take a couple of snapshots.
So maybe do a V or a hi or something like that.
Oh, that's okay, sir. I think
okay,
that will be good if they will not say he, hi. Good, guys. So I think on behalf of VLSI expert, yes, I can say it's too good, I would say. So even now, sir, you can see the 179 attendees are there.
Yeah, that's, I mean, actually, when we started this, honestly speaking, I was hoping for 100. You know? And so we got 1,600 registrations, and first 2 days was close to 500 continuously. Then it has been 350 plus and so on. So it's been phenomenal. Okay. So.
Great. So before everyone just switch off their camera and just log out also. So we want to discuss this internship program also. So I think I gave a very small presentation very first day. I will not take too much of time right now because it's already 1:30. So what I'm going to do, I'm just sharing my PPT and we'll just go through that particular PPT in a very fast forward manner. If any one of you have any question, so I think that's going to be I think that should be the best way. You guys can just let me know. So this is the internship program, 6 to 9 month of duration. This is free for everyone, and the eligibility criteria is like, except the second year students, I would say everyone is eligible for this internship program. And you just I'm sure like by now you have attended your all the conferences like this NES2020, you have attended that particular part. So we have your participation number, so we want to check your one thing, like, okay, how serious you are. Now when it comes to the project and profile, so this particular list which you are seeing, it's still increasing. So in the last 2 days I have received a couple of more queries where like in a IP development point of view, like in a IP development and IoT side also. So I'm receiving a lot of inquiries, I would say. There are a lot of people, they are ready to mentor you guys, and they want to engage you also. So I didn't get a chance to update this particular slide, but maybe when you are going to fill the form, then definitely you will get those details there. Similarly, on the company point of view, so right now you can see there are only 4 companies, but there are 2 more companies. They are ready to participate directly. Means when I'm saying the company point of view, they are talking about, they are ready to give their name here. There are few more mentors. So now the number, if you will just sum up right now, the number looks to you like if I'm not wrong, it's at 21, the previous number, but now it's number become 25. That means we started with the 10 people, like between me and the Savia and SIT lab. We thought, like, okay, we will just go with the 10 interns, but now it's increased, and now we are going to go with the 25 interns. So we are going to hire that thing. And so now if you will see, there are 25 people. So yeah, so someone was just checking, like, okay, whether the photo session is done. Yes, photo session is done. You can switch off your camera if anyone wants to do it. So yes, so this particular part, we are happy, like, okay, we are scaling up, and I'm very happy, like there are people from the industry, there are people from the different not the people, the different companies, they are ready to be part of this internship program. Now, when it comes to the selection process, one of the selection process was just to attend the NES 2020, which I think is good. And there are the written tests. So a few of you are just asking, like, okay, when the written test is going to happen, and when the quiz is going to happen. So me and Saroj sir, we have decided, like, in a quiz during the session. Initially, that was our plan, but somehow we both of us were very tie up with the other things, so we didn't get a time. But yes, participation numbers we have. So Zoom has a very good statistics, so we can see, like, okay, how many of you have attended just for 1 minute, 2 minute, or just like the whole day. So don't worry about that particular part. You will get the weightage of that things, because when we are going to share this number with the selection team, then definitely they will just need to understand how serious you are toward this particular internship program. Apart from that, the long quiz, this is a 2 hours, now it's extended. So because more and more profiles are added here, now it's going to be the 2.5 hours, and it's going to be not a very basic quiz. So don't think like, okay, it's going to be, we are going to ask you what is the truth table of an AND gate, or the AND gate is going to be in that particular way, like, okay, we want to make sure 2 things. One is you have a respective, sorry, you have a respective skill set. So when I'm talking about you have the respective skill set, that means there are a couple of companies, they need the person who are skilled already, so they don't want to train you, and that's not the purpose of this internship program also. But there are few people, they are okay to train you for the couple of months, maybe the 1 month or the 2 months. So for them, the your basic understanding is good. So the point is, like, this written test, this is going to be the online, and is going to be between 20th and 25th of December. Why? The reason I'm not talking about in terms of the exact date, because lot of back end work we have to do, and we are working on that particular part. Another thing is there is a screening mechanism. So it's like we are going to screen you guys on the basis of a lot of parameters in terms of the forms which we have asked you just to fill, and there are a couple of things which we have to still collect with the mentors. So we will update you about the written test, about this free internship program. All of we have your mail IDs, so you will receive a mail from our side. And I think a few of you are already connected with us on our the this WhatsApp group that created by SIT. So you will get there also. And then after that, it can be the 1 round or the 2 round of interviews that will be there. So that's there. Yeah, internship is online for the next couple of months, and then depending upon the mentors and the company, they will ask you just to join offline, and obviously you will get that particular detail the very first day. So like when we are going to interact with you, we will communicate you like, okay, this mentor or this company need you at their respective location after so many months. So it's not like once the internship is going to start, then we will say like, okay, just now just come. So expectation we will set from the very first day, like, okay, this is what we are expecting from you. Just one thing I want to highlight, like there are a few mentors, they ask me like, okay, if it is a 6 month of internship and if they will spend some time with you and they will assign you certain programs, if you get placed in between, then what is going to be happen? So as such, you're free to do whatever you want to do, but still obviously if someone is spending some time with you, they need a certain commitment from your side. So they just need that particular part, like, okay, at least you should be honest and you should just commit toward the whole internship program. From our side, we are not committing anything. So we need a lot of commitment from you, but we are not going to commit you from the placement point of view. So don't think like, okay, you will get a placement from this particular program. But yes, from the VLSI expert side, I can tell you like, okay, if you perform good, then definitely I'm going to add you as a part of my placement program. So my placement program, there are a lot of activities we are doing, so I will add you there. And that's something which I can do individually. There are a couple of companies whom we have discussed, and they said like, okay, they are going to convert that internship into the paid internship if they like it, if they like your performance. And that conversion can be in the maybe after 2 months, 3 months, or maybe it can take 6 months. So as such, we have discussed with them like the very first day, let us suppose if you are on their associated with any company, so we have already discussed with them like you're not supposed to sign any bond, because that's a very some questions when people are asking me offline like, okay, whether we are supposed to sign any bond. So you're going to, so there is nothing like in a bond or the commitment you have to provide the very first day. But yes, if the day they are going to start paying you as a stipend or something, then definitely they may ask you the commitment on the paper. So that's the thing. So in between, I can say if you face any problem, if you have any concern, I'm always there, and you can ping me any point of a time. We have our own application also, so that the way we are going to create basically a group between you and the mentor, we will do it through our app. So the reason we are not going to use the any like WhatsApp or something, maybe there are a couple of uh, uh, mentors, they don't want to share with you their phone number. So we have our own app where the privacy is going to be maintained. So we will use that thing. We will pass you all those information later on over the mails, or maybe the way we want to communicate with you. Yeah, so that's all from my side. Now if you have any question, and you can just want to ask me, just tell me.
Puneet, I think some of the first questions which are popping up right now is a lot of participants are saying, oh, I just used YouTube. How are you going to get my attendance?
Okay, so from the YouTube point of view, we have a mechanism. Don't worry. So the thing is like maybe what you have to do, you have to just pass one more quiz, I would say, because obviously those who took a special thing, like, okay, they spend almost like 3 hours, 2 hours, just maybe they were not interested, but at least they logged in and they were live on the Zoom session. And so for them, we don't want to ignore their effort. So what you have to do, you have to just do a very small quiz once again. That's the plan right now. and we will communicate to you. So if you have watched this particular these sessions over the YouTube, then obviously before that I'm sure like you have registered for this particular event, because that's what we did it. So for all the registered candidate, I would say in that particular, for all the registered candidate, if any one of you have attended the YouTube channel, in that particular case, they will get a mail from our side for one small quiz or the test. So you have to do in that particular way. Someone was asking about the exam pattern. So exam pattern is going to be the basic courses, some advanced courses going to be there. There are the section wise thing will be there, and you have to just attempt all those sections. So it's not like there is any specific cutoff in a particular section, but on the basis of your profile, on the basis of the project which you are going to choose, there can be a specific cutoff for the mentor or for the companies. So that's going to be there. So that's a part. So the thing is, see, I think in this way, we as a like I would say the this particular initiative we are doing because we want to connect you with the different companies and the mentors, and every mentor, every company has their own criteria. So what we are doing, we are not just overriding that particular criteria. We are just telling like whatever with their criteria, on the basis of that we are going to do it. And that's the reason it's going to take some time. There are a lot of things which we are compiling. We will do it in the next 1 week, and we will communicate to you accordingly. I think that's all. Any specific question? Written test, interview? Yeah. So written interview, yeah, is going to be in a Zoom, or maybe it's like you have to be online. So it's not a telephonic. Maybe using the Zoom or some similar type of thing. We will do that particular part, because we don't want like you just ask anyone else to attend your conference, then the quiz and the interview also, and the project and everything is going to be done by someone else. So we don't want that particular part. So we want to see your face. So that's the reason this online video thing came into the picture. So yeah, that will be there.
Somebody's asking if there is a stipend. No, that's right. It's free. Free.
Yeah, so I think that's the free of cost. That's what we have mentioned. So free internship program. So from right now it's free. And if any mentor they would like to pay you, then it's good. If any company they were saying like okay, they are ready to pay you certain stipend amount, they will do that particular part. So that's depends on your performance. If you perform good and they don't want to lose you, then definitely they will do that particular thing. But as such, from our side right now, it's a free internship. Free in the sense there's no commercial is involved. Neither you have to pay anything, neither we are going to pay any stipend right now. This the purpose of this internship is mostly just to give an experience. So there are a lot of buzz, I would say. People are screaming here and there that we don't have any job because we don't have any experience. We don't have any experience because we don't have any job. So we are just trying to fill that particular gap right now. Okay, sir, I'm done.
Okay. Yeah, that's just maybe one last point. The numbers, at least from our side, for example, we said 4 people in the circuit analog side of it. But if we find that there are like 7 great candidates, we're not going to say no. I mean, we probably do that if we get 5 candidates, maybe not 10 or 12 or that thing, but those are a little flexible. And same goes the other way, right? We don't find any. I mean, if we find just 2 good candidates and others we just don't, we might drop that as well. So just wanted to put that out there. At least from our lab side, it's flexible. That 4 number is flexible. So if we find some really good guys interested and they have the skills, we'll take more as well.
So someone was saying they are not in a WhatsApp, so don't worry, we will mail you.
Yeah.
So that's
email
what I'm saying.
would be the mode of communication for the internship, so don't worry about the WhatsApp. Yeah.
Okay, so the initiative is going to be continued next year also, because we have not started the VLSI in the college syllabus. So I think we don't know what is going to be happen in the next day. So we can't comment on this particular part, but that's going to be continued the next year. So yeah, but yes. So like August when I started with the 5 interns. So like that's the program. Now it's just a couple of months. Now it's the second program free internship. Maybe if it become very popular, I can do it in the next uh, every quarter. So maybe in a collaboration with a couple of companies. So but I think the question which you have asked, maybe the best time you just ask me next year.
Actually, it all depends on you guys. If we get good guys, the companies are benefiting, it will automatically grow.
Yeah.
So,
Okay, great. Thank you, sir. Thank you. I think, sir, we are almost done.
Yeah, I think that's it. Don't have, is there anything else you want to project? No, I think that's it. So I think we can sign off. Great program, and look forward to seeing you all somewhere, another conference, webinar, or job or internship. So thanks a lot, you guys participating. Like I just said, you're the guys who make it successful.